Okay, good afternoon, everyone. We are going to continue our session, okay, for the CFPS. And today we are going to continue our session from the section 14, detection and alarm. In the last lecture, we discussed this section, okay. And what we have already completed is basics of fire and science, section 2. And now, then we started section 14 because I already discussed that most of the major sections, okay, major discussions that we are going to continue with, they are already discussed in basics of fire and science. So like this, it will be easy for us to continue and cover up the sections for the examination also. In the last section, we discussed about the fire panel, okay, fire alarm control panel, the type of alarms, the type of signals. Then we discussed about the different type of systems, which included like protected premises systems, central station systems. Then we discussed about the proprietary systems, auxiliary systems, remote station systems, and emergency voice alarm communication systems. Then we discussed about various different types of detectors, in which we had complete discussion over the smoke detectors, heat detectors, gas detectors. And we were discussing about the notification appliances, in which we had discussed about the decibel values that are permissible by the NFPA 72. Today, we are going to continue our session with the notification appliances. Yesterday, we discussed about, in the last class, we discussed about two types of notification appliances, a private port and a public port. Okay. And based on that, we discussed about their certain requirements by the NFPA 72, how we have to make sure that what is the noise to noise ratio, okay, through door, wall, and how we can calculate the total sound pressure level that can be received at the human ears. Okay, so today we are going to go on with the notification appliances, but today we are going to discuss about the visible notifications. Okay, what are the visual notifications? Okay, and why they are required in occupancies. Okay. So in the last lecture, we discussed about the notification appliances. In that, we discussed one of the major topics. If you remember, last time I discussed that the notification appliances, the permissible value for the notification appliance is 75 dBA. Okay, that is enough for an residential occupancy to aware documents about any type of an hazard. This value can go up to 100 dBA if the person is on sleeping pills or they have hearing impairment. So whenever a notification appliance, okay, of 100 dBA audible is applied, okay, whenever a notification appliance of 100 dB or above is required, okay, as an audible notification, okay, whenever the audible notification reaches 100 dB or above, okay, a visual notification is necessary. In visual notification, the most common type of visual notification that we discuss are the strobe lights, right, flashers, okay, that have certain intensity that is available, okay, up to a point which is available for the people. Visual notification, okay, first of all, we need to understand that what type of a visual notification is applicable for our occupants, okay, and how this visual notification can be directly read out through the, or can be seen through a human eyes, okay. So for example, let's say that if I have any type of, first of all, we need to discuss about a vision that is available for a human being, okay. So let's say that I have 3 visual notification appliances available in any occupancy, okay. So based on the visual notification appliances that are stored at a specific location, okay, and a person who is actually standing somewhere near. So what happens? There are 2 types of effective visions that are available for the person, okay. Now this vision on the top, okay, of the flasher is not a direct vision, means a person cannot see a directly towards the flasher, that is on the peripheral side of the human eyes, okay. So that is why this strobe light is at a peripheral vision. Okay, it is at a peripheral vision, okay, means directly he cannot see it, but there could be a type, during the flashing he can sense that due to peripheral vision, a portion of vision will be available, indicating that there is some type of disturbance, okay, that he can identify. Then comes the acute vision. Acute vision is usually an acute angle that is nearly equal to 15 degree of the human eyes. So this angle, okay, is an acute angle, okay, with this much of a deviation. So this angle is usually 15 degree, okay, and it is known as the acute or focusing angle, okay, of a human eye, or focusing angle of the human eye, okay. So one is the peripheral vision, okay, peripheral vision in which a portion of a flasher can be viewable. So you can see here, I can, in other words, I can also say that this portion, the portion of these two lights are usually covered by the peripheral vision. But this portion and any other visual lights coming into acute angle are directly visible towards the human ear. Okay, so visual notification is important, but up to a point where we have to understand that the ceiling height of the visual notification is up to a point where the acute angle, okay, means the flasher is up to a point where the person can actually view the acute angle, okay. They can have a direct vision of the visual notification, okay, but this is not possible in every case, okay. So that is why whenever we are discussing about the visual signals, okay, or visual lightning or visual notification appliances, this type of a scenario is always not possible. There are usually obstructions that are available, and that is why sometimes what happens that we have to go for indirect signaling, okay. So indirect signaling could be like a reflection of light on a specific material and then approaching towards the human eye. Why? Because of the obstructions that are available. Let's take a scenario. Okay, let's say that if I have any, again, visual notification appliances. Okay, okay, throughout the ceiling. Now I have certain obstructions that are available in between. Now, if a person is available somewhere here, there is no acute angle here. He cannot have a direct access towards the acute angle, right? If a person available here somewhere, okay, he can have a peripheral vision here, okay, but a direct access is not available. So at a specific distance means if the person changes his position to a specific distance, okay, this angle can come into the acute angle, okay, and that can be considered to be a direct signaling. Okay, direct signaling. But on the other hand, if I'm looking at here, okay, the light, now this person has no acute angle here available within the obstructions. So what is the scenario here? Here, the light will always reflect and then again come here. The light will reflect and then again it will reach to the human eyes. So this type of signaling is indirect signaling. Why direct signaling or indirect signaling is important? Okay. A direct signaling means that the strobe light should be considered of up to an illumination. It should have an illumination, okay. That should always, you can say always point up to a point. Like let's say if I am having a direct signaling of a visual notification appliance, the illumination should not be of that much high. Like let's say uh, one notification appliance might reach towards an intensity of 1000 candela, okay, and others might reach 750 candela, okay. So what happens once the illumination also travels through air as a medium, okay, the intensity decreases up to a specific distance, okay. So for that purpose I need to understand that how much amount of intensity is usually required. So if I have two devices that is available with me and I have to select between direct signaling and indirect signaling. So of course, okay, let's say that I'm just taking as an option, okay. So let's say that my direct signaling, I will always keep up to 750 candela. If I have 750 N, 1000. Why? Because it is directly, without any obstruction, without any reflection. But whenever it's an indirect signaling, so it means that a light is going to be reflected. So here the intensity can be kept higher. So here I can keep up to 1000 candela. Okay. What are the requirements of NFPA 101 for the egress lighting or visual notification appliance is totally different. Okay. So egress lighting, usually it says that that egress lighting should be 10 lakhs, okay, per square. So the minimum lighting should be 10.77 lakhs luminations, okay, luminance. So, but 1 foot candle, you can say simply that the minimum illumination should be 1 foot candle, and 1 foot candle, okay, or if I want to convert it into lux, I will say 10.77 lux, exactly, okay. But in the visual notification, two things are very important, okay. One is the source intensity that we have already explained here. Okay, I have to increase the source intensity. Why? Because based on the distance it has to travel, or based on the objects or obstructions that it is available. Okay, so if there is no specific obstruction available, then the source intensity can be reduced. But once I have obstructions available, what I need to increase the source intensity. Okay, why? Because there is going to be reflection available. So I want, so now that this signaling is not a direct signaling, so I need more intensity so that the reflection of light is actually applicable towards the human eyes. And based on that, I will get an I can easily provide a peripheral type of a signal towards the human eye so that he can be aware of any type of a situation. For example, if I'm working out in a library, okay. Now in the library, I have big shelves. So usually people are using earphones. So whenever there is an audible notification, there is also a visual notification in the form of flashers. And when the flashers are placed above the racks, okay, so there is an obstruction. Acute angle is obstructed. So now this acute angle will be obstructed up to a point, okay, where I'm not going to be able to see directly what is, happening. Okay, so what I want an indirect signaling. For indirect signaling, I need the intensity to be much more greater, because the light is going to reflect and there will be loss. Then it will again reflect and maybe it will reach towards a point. So maybe I'm standing in the shelves. So through the shelf glass or through the furniture itself, I'm looking some flashing that is available, some reflection is giving, and it's giving in the form of a flasher. So what happens that I tend to identify that there is some issue, then I try to look it around. Like for example, sometimes I don't even see the police vehicles, okay? But usually when I'm looking at the walls of the buildings or in the streets, I tend to find out that there is some red blue lights that are illuminating up to a point. So I tend to identify that there is a police or ambulance that is nearby. So that is basically based on the first important factor, that is the intensity of the source. So intensity of the source is kept up to a point where you have to, a designer has to, or a professional has to understand that whether my occupancy is actually focusing on the acute angle or on the peripheral vision. Okay, so whenever we have large shelves, storage areas, rack areas, okay, so where too much obstruction is possible, there the acute angle possibility is not there. So there you will find out that the intensity of the illumination is usually kept far greater. Okay, but wherever we have acute angle, means that flasher, that is acute angle where human eyes can directly see the visual notification, okay, the flasher, there we have to make sure that the intensity is usually kept within the consideration so that the human eyes are not damaged accordingly. So based on that, first of all, the visual notification, the first important thing that NFP72 addresses is that in the visual notification, the first important thing that should be kept in mind or kept in consideration while looking or designing any type of a visible appliances is the source intensity. Then comes the source illumination at some distance from the source, meaning illumination at a specific distance. Now, what effect does the illumination at a distance has? As I said, that when the source increases, right? The distance from the source increases, the intensity of the illumination also gets affected. And this effect is not only because of the distance, but there could be various, this effect can be considered to be more adverse, okay, when there is environmental conditions that is occurring, like for example a foggy environment, moisture available. So what happens that the intensity of the illumination also tends to reflect in the shiny particulates of the mist or the fog. Okay, so from the illumination at a specific distance, the intensity also reduces. Okay, so illumination distance not only it decreases the affects the source intensity, and that source intensity is not affected only by the distance but also by the environmental conditions. So sometimes what happens that wherever we have it, like in oil and gas industries, okay, they usually have flashes that are available on the top of the hazardous area, not only not only to just inform people at a control station that is located at a remote or at a specific location outside the facility. Okay, but also if there is any type of an authority having jurisdiction, meaning that your civil defense, if they are going to approach it, so they also from a specific distance they will know that how much that the flasher will be providing them a signal towards the location of the hazard. Okay, so it helps in both ways. So that is why whenever we are going to design any type of an illumination for a visual appliance, we have to see whether we have to keep 1000 candela, we have to keep 750 candela. Okay, so whatever the candela that I have to always keep, okay, we have to identify that what type of I mean what is the purpose of the visual notification, whether it's just to inform the people, okay, or it is to inform for a wide area, meaning towards a larger area. A larger area means more intensity of the illumination will always be there. Okay, so that is why the illumination of the flasher is always kept as a type of an as a type of an calculation that a person has to identify to keep, a person has to keep in consideration the source intensity and the illumination at a distance, okay, from the source. These two factors should always be kept there. Now how much candela that flasher can give, it depends upon the type of the device. Usually the devices, like if I'm saying 1000 candela, okay, so some devices give 1000 candela in 0.1 second, okay, of the activation. Okay, and what happens that once this distance, okay, some devices might reach 750 candela, okay, in let's say approximately about 0.2 seconds. Okay, so it depends upon different types of devices. So different, whatever the type of device I'm going to use, the first important thing is that I need to know the candela effective. What is the candela effective? I need to make sure that acute angle is providing enough visual notification for the people to realize that it's a threat, and indirect signaling also, enough illumination should be there, okay, to identify whether the person is able of the is capable of understanding the threat or not. Okay, so whenever we are talking about the intensity, okay, of the illumination or the candela effective, CDEFF, okay, what is the candela effective? Usually whenever we have a source, let's say that this is the source of light that is available with me of a visual notification appliance. Okay, so now this visual notification appliance, whenever it's going to give me an illumination, what will happen? The illumination will be given, first of all, it will start in a conical way, right? It will start in a conical way, okay? And then as soon as it reaches up to a specific distance, it's getting more and more wider. So that is what I was saying, illumination at a distance from a source, okay? So what happens? The illumination becomes more and more wider. So intensity reduces, okay? So let's say, if I'm going to say that from the source, near towards the source, okay, if the distance at a specific distance, okay, the illumination will be reduced, okay. Like for example, if I'm saying at one point here, it's 1 foot candle, okay, then I want to measure it at a specific distance, maybe at a distance of increasing by 1 square feet of a distance. What will happen? The illumination will be reduced to 0.926. So illumination from the source, okay, illumination at a distance from a source, what will happen? It will always gradually reduce its intensity. Okay, so that is why we usually say when more the distance, the intensity can be affected. And at a specific, at the end of the conical view, if there is any type of an environmental changes, okay, it greatly affects the visibility. Okay, so for that purpose, it is very important that what is the candela effective that is usually required by us. Okay, so and candela effective is the amount of illumination reaching up to a point towards the human eyes. Okay, that can provide the sense of threat, okay, usually. So NFPA 72 has a different type of table that is available for minimum intensity strobe lights, okay, that is required based on the room sizes, okay. For example, one of the, if you go for the complete table, okay, so usually, okay, a single strobe, okay, can give approximately 15 candela effective, okay. A single strobe light for a room can give 15 candela effective of illumination, okay. Okay, so once the room sizes increases, okay, there's a complete table. So once the room sizes increases, okay, what will happen? Then we may require multiple strobe lights, okay. So based on that, 15 CD, 15 CD, 15 CD, we may require 2, 3 or 4 even, just to make sure that the strobe light is enough for us, okay. So similarly, if we are talking about any type of higher strobe intensities, okay, for non-sleeping areas, okay, like for example, the areas where we know that there are hearing impaired people, okay, and they may require higher strobe intensities, okay, and so that people that if they are not aware, at least illumination will disturb them, so that they will know that how much I mean there's any type of threat available. So for hearing impaired areas, okay, the intensity of the strobe light is 110 candela effective for hearing impairment people. It's 110 candela effective. Okay, so the intensity is usually increased. Yeah. So like this, we can use the NFPA 72 requirements. So based on the design goals, the NFPA 72 has provided a complete chart on it, okay, table. And based on that table, we can identify that what is the room size and what will be the candle effectiveness that will be required by our strobe lights or flashers, okay. But usually whenever a professional is actually providing, there are certain design parameters that can actually create a type of a challenging environment for the professionals. And based on that challenging environment, okay, they may find it like too much obstructions available. They may find too much, you can say the distance is too much large. Okay, so based on that, they can have confusions and they can follow, they can use like codes in a wrong way. So that is why two things have to be always kept in consideration whenever you are designing. First is the source intensity, okay, and second is the illumination at a distance from the source, okay. So based on that, we have to make sure that if for a, just to keep as a reference, okay, for 20 square feet of a room is there, then I require a 15 candela effective strobe light is enough for me. But for people where there is where people are hearing impairment, okay, where the visual signal is the only one that can provide a signal, like a non-sleeping areas, there the sound, the visual notification or the stop light can have the intensity of 110 candela effective. Okay, so 110 candela effective is the unit indicating that the intensity is enough for the human eyes to identify it as a threat. That is the effective of candela. Okay, and this effectiveness will reduce with the distance. Once the distance is more and more larger, this effectiveness will totally reduce. Okay, so there will be a point where the notification flasher, strobe light or visual notification is actually blinking, but a person is not paying attention because the intensity is much more lower. So it does not provide any type of peripheral vision signaling towards the human eyes. Okay. So let's discuss about the carbon monoxide household detection. Okay. Carbon monoxide, we have discussed, it has three very important properties, right? The first thing is that it is colorless. Okay, it has no odor. Okay, and it mixes up with air. Okay, for that purpose, we have also discussed why it mixes up with air, because carbon monoxide molecular weight, we have calculated it, right? It's approximately equal to the molecular weight of dry air. That is why it is very difficult to detect it. So usually most of the deaths or most of the incidents that we have seen is that carbon monoxide, it tends inhalation in the human body. Okay, it tends to remove the oxygen from the human body, and a person who is usually in the sleeping, okay, tends to die. So basically, carbon monoxide is also known as silent killer. One of the most toxic and one of the most you can say uh, dangerous gases that is available, and it is usually produced by the half combustion of carbonaceous fuels. Mostly we have hydrocarbons. Okay, whenever they are whenever combustion process starts in hydrocarbons, okay, carbon monoxide is released in lethal concentrations. Anyways, carbon monoxide household installation, okay, can be followed by NFPA code, that is NFPA 720. Some questions in the examination will be related towards the NFPA codes also. Okay, so they may ask you some questions related towards the codes. Sometimes the codes are very easy. Sometimes they may ask you difficult questions also. Like, for example, they may ask you NFPA 850 refers to, and or they may provide you that the code for standard for the installation of stationary tanks refers towards which code. Okay, so for all the questions regarding the codes, we have to just go to the index. In the index section and the end section, we will find out all the NFPA codes. And during the end of the sessions, we will go through the index and we'll discuss how to highlight the index and what is uh, the parameter, what are the key points in the index. We will discuss that. And during that discussion, I will show you the end section. End section, we can discuss, we can see that it has mentioned all the codes from NFPA 1 to NFPA 5000. So whenever code question comes from the code, if you're if you know the answer, okay. If you don't know, no issues. You just directly go to the end section and you can find out the code itself with the answer. Where code and its description or the heading is usually given in the index. Okay, so the code that we tend to follow for the carbon monoxide is NFPA 720. Okay, now where should be a carbon monoxide system installed? Okay, so whenever we are talking about houses, okay, in residential occupancies. Okay. So whenever we are talking about residential occupancy, so what happens in the residential occupancies, we have various different types of floors, flats that are available, right? Each and every floor has specifically like 10 rooms. Okay, and each and every room has a separate connection for the gas with a specific meter, right? Means gas meter is there with the pipelines. Okay, so now if I want to install a carbon monoxide detector, it means each and every house has its own combustion heat and heating appliances, each kitchen, right? So what happens in the residential occupancies? Okay, here the carbon monoxide detectors are usually installed outside the sleeping area. Means in each flat there should be one, and it should be installed very near, in a close proximity of the bedrooms, okay, where the people are sleeping, so that if the gas somewhere it has leaked out from the kitchen, okay, and it's reaching out, or if something has started a the production of carbon monoxide in lethal concentration, okay, before it reaches the bedroom where people are sleeping, the alarm should trigger, so that people will know that there is any type of a carbon monoxide release is there, and they can start taking appropriate actions. But this strategy changes whenever we are in hotel occupancies. In hotels, okay, what happens? We have rooms available, but the only issue is that, first of all, the room quantity is too much, right? And secondly, the hotels usually have common kitchen. In the hotel rooms, the kitchens are not available in every room, right? So the source of carbon monoxide is also from this point. right? So in hotels, okay, the carbon monoxide detectors are usually installed inside the kitchens. Okay, they are installed in the kitchens where the source of carbon monoxide is usually there. So from the source, if there is any leakage, they will know so that they can take appropriate actions. What are the actions that one should take whenever a carbon monoxide is detected? Okay, so the first appropriate action is, because the carbon monoxide, what it tends to do, it tends to remove oxygen. Okay, so what you have to do, you have to make sure that a carbon dioxide concentration is diluted, because the more concentration, less oxygen available. So for that purpose, okay, what you have to do, you have to make sure that the carbon dioxide or oxygen availability is up to a point, okay, where a human or the people occupants can continue breathing. So for the first appropriate action is that we have to open the windows so that we can ventilate the area, allow more oxygen to come inside, and carbon monoxide to move outside the facility. So dilute the concentration of carbon monoxide. That's the first step. Second is that we need to assess medical condition of the occupants. Okay, if someone is under an unconsciousness stage, because when the carbon dioxide is removed up to a specific concentration from a human body, the first thing is a headache. Okay, initially headache, nausea, then eventually what happens, that a person may go into unconsciousness, and then afterwards death also. So assess the condition of the occupants, okay, if they need any type of medical attention. Okay, and if necessary, if you know that, okay, the concentration is not stopped, okay, and carbon monoxide is still increasing, okay, and any type of, because carbon monoxide, if it's releasing, or it's because of the hydrocarbon, so okay, availability, so you may require to call the public fire service center for assistance. Okay, so three important steps that you have to take whenever a carbon monoxide is being detected into the atmosphere. The most important thing is that we need to ventilate the area, okay, because it removes oxygen very effectively from the human body. So we open the windows so that we can allow more and more oxygen to enter the facility. What is the temporal signal that is allowed by NFPA 720 and 72 for carbon monoxide? So carbon monoxide is a single tone temporal 4 pattern. Okay, carbon monoxide signal is a temporal 4 pattern. Last time we discussed, NFP 72 says that the evacuation signal should have a temporal 3 pattern. Carbon monoxide, the pattern is temporal 4 pattern. We have discussed this one. 4 cycles of on and off, and then off, and then again 4 cycles on and off. Okay. So more likely it is going to be in a single tone. So a single tone temporal 4 signal is going to be 2 and then it will going to be silent. Then again it's going to be 4 stops of on and off, and then it is going to be silent. So that is a temporal 4 pattern for the carbon monoxide signal. In the examination, they can ask you about the temporal patterns. So the temporal patterns are usually, okay, okay. As soon as like that pattern, evacuation signal, sorry, is temporal 3 pattern, okay, 3 tones of on and off, and temporal 4 pattern, okay, 3 stops of on and off, okay. So that is for the carbon monoxide temporal 4 pattern. In the examination, they can ask you that carbon monoxide signal, okay, and then they can ask you about the this one, sorry, carbon monoxide or evacuation signal. Okay, I believe that we need to have a quick view over chapter 5 briefly. Okay, let me just check chapter 5. Yeah, then we'll go for some sample questions. Okay. Okay. Inspection, testing, and maintenance of fire alarm systems. Yes. We will discuss about that one. Okay. And the probability failure rate, okay, that is not actually part of the syllabus. Okay. But uh, usually in the fire alarm systems, operation and maintenance failure, let's say that if we have discussed in the in I think so maybe we have I've asked this question in the start also in the ITM, installation, testing, and maintenance of the fire alarm systems. The first device that we usually check in the fire alarm system is the batteries, right? We have discussed this. Okay. Now, uh, in the fire protection handbook, what they have done about the inspection, testing, and maintenance of the fire alarm system. Okay, what they have done is that they have provided us the probability of the cause failure. Okay, and then analysis. Okay, that how much probability is there that a fault can occur. Okay, but but when we were discussing about the fire alarm systems in the start, okay, we discussed some of the parameters that were for the inspection, testing, and maintenance. Like for example, okay, usually whenever a fire alarm system is being tested, okay, the first important thing that we do usually test is the batteries of the fire alarm system, because whenever the primary power is cut off, okay, this is from the NFPA 2 in the fire protection handbook. They have gone to a different section. They have described the same parameters but in certain paragraphs. Okay, other than that they have already moved on towards the failure and probability. Okay, that is not part of the examination. The important considerations of the installation, testing, and maintenance of a fire alarm system is the inspection, testing, and maintenance. First of all is that in a fire alarm control panel, we usually check the batteries of the control panel. Okay, because whenever a fire is going to occur, the first thing is that the authority power will always be disconnected. So your all system is going to run on the batteries. Okay, so your all system is going to run on the batteries. Okay, now when you move on towards the second important point of the inspection and testing and maintenance. Okay, now second important point for the maintenance is that what happens is that for like your devices. Okay, once your devices are faulty, okay, so you should get approximately an signal directly towards your control panel. So your devices, initiating devices, should be well tested, and the sensitivity should not be reduced. Sensitivity of a smoke detector should be 2% per centimeter, meaning that that's a chamber. Okay, when it occupies any type of a mist or any type of a smoke accumulated inside a chamber, okay, 2% per centimeter sensitivity should be there minimum for the detectors. If it's greater than 2%, it means that the sensitivity is lower. It means there's a delay in detection, a delay in detection, again, delay in activation of the system. Okay. So, like sensitivity should never be reduced. Okay. And whenever we are testing our devices, you know that we usually use testers, smoke testers. They create a type of a mist fumes inside the detectors to create or to analyze uh, what is the probability. Okay, that I mean how the system is going to, how much reliable the system is. Okay, usually then our semiconductors, resistors, capacitors inside a control panel. Okay, but usually nowadays control panels, they are more intelligent, and when they are intelligent, okay, so what happens that they tend to provide any type of open circuit, short circuit fault directly on the panel. So you know that any type of end of line resistance, any type of circuit resistance or capacitance has already blown up. So you may need to repair, or you may need to send it back to the manufacturer for a replacement of the hardware. So when you're talking about a bathtub curve, right? So we're discussing that what is the bathtub curve? Okay, so that is what I was actually mentioning to you guys. That a bathtub curve is actually the number of incidents that has caused. Okay, usually what happens is that failure rate. How much type of a failure rate is there? Okay, like say if I have a Siemens panel now the probability of the Siemens panel failure rate is that per year the failure rate is up to a percentage. Okay, let's say my Siemens had one of the panels. Okay, I don't want to take the model, or that had a we had a very tough time with that specific type of a control panel. Okay, so now what happens at the failure rate means that any type of electronic component failure, meaning any type of resistance that is blown up, any type of fuse that is blown up, any capacitor that is blown up, okay, any type of burnings or any type of markings, damages on the PCBs, okay. So what happens that you tend to calculate that what is the failure rate that has gone per year that we need to calculate. Okay, so let's say that usually the system runs 365 days per year. Okay, and out of that 365 days per year, okay, how many times the failure of an electrical component has occurred? So you calculate a percentage out of it. So that percentage, 2%, 3% of failures, or 5% of failures have been there. Okay, so once you calculate that percentage, okay, you multiply by the number of years the system is going to run. Okay, so let's say if a system is showing 5% of a failure per year, so it means by the end of 5 years, the component is going to have 25% of failures. You got the point? So it means that a whole component indicating again, what are the whole components that are available? Means that a whole complete working days, 365 working days. Out of that, 5% means that, let's say that this 365 days, okay, 5% of these days is a component failure. So in 5 years, okay, number of days means 25% of the failure rate will be there. Okay, so what you tend to do is that we tend to calculate that failure rate. What is the lifetime of that control panel? Manufacturer usually provides us the lifetime. Okay, like for example, it will provide us that this during the auditing, during the analysis, it tends to provide us that. Okay, just a second, please. Okay, so like for example, the kitty provides me information that, okay, my panel is going to run effectively for 10 years. Okay, so we are going to provide that if there is any type of a hardware failure, okay, any type of electronic component failure, what we are going to do, we are going to provide you any hardware in return. Okay, so up to what point they say, let's say they say up to 5 years if there is any type of failure. Okay, so what we tend to do, we tend to see throughout the 5 years, because now in the 5 years the manufacturer is providing me the warranty that we are going to provide you the components, but that doesn't solve my problem. Why? Because I'm not going to purchase a system for 5 years. It means that the first 5 years is going to provide me the components. I need to know whether this device is actually reliable for me or not. Why? Maybe I need 25 devices for my next project, right? So then I create a bathtub curve, okay, to see what is the statistical failure, okay, during the passage of time, okay, whether it's consistent or whether it's fluctuating higher or lower. Okay, so this gives me much more idea of whether I'm going to go for that manufacturer or not. Okay, so this is how we can actually identify. So like for me, it will be easy for me to identify whether I want that material or not. Okay, because in the 5 years, okay, even though they are providing me the hardware, but the failure is too much high, meaning that every year if I have to purchase 5 components, okay, for the 5 years it's not hectic for me, but after 5 years it's going to be very hectic for me. How I'm going to arrange the hardwares? Okay, the fault ratio is very high, so it means that this component is not good for my projects. Okay, I need a more reliable system, right? So that is the usually we use the term like infant reliability. Okay, and like in the start we usually say infant mortality region, sorry. Then we have the failure region, statistical failure region, and then we have the end of life region. Okay, how much by the end of life, okay, means at the end of, let's say, 10 years, okay, how the system is, how long the system is going to run. For 5 years, if the failure is very less, okay, what we tend to do, we tend to go for that system. Okay, why? Because I know if 5 years it has given me like 3 or 4 component failure, it's fine, no problem for me, because it's a duration far more greater. So I can go for 10 years. Okay, so 10 years means 8 components. Then I can plan it ahead at how I can use the devices based on the manufacturer. So bathtub curve gives me an idea of my failures, how many component failures are there, and whether I can depend on this system or not in the future. So usually the facilities manager, they tend to calculate this for the future, that in 5 years, okay, 3 faults were there. It means in 7 years or 8 years, I will get maybe, even if it's same also, it's fine for me. I mean, we can work it out, no issues. It's not headache for me. But if in the 5 years, 15 components, 17 components are a failure, means the system is not reliable. So there we calculate a statistical region. Okay, that if you want to draw a graph or a curve, okay, so the statistical curve, okay, usually the failure rate, okay, may be higher in the start, but what happens to, because when a manufacturer is giving a component, there could be any type of a failure, it could be higher, but during the passage of years time, it remains same, consistent. Okay, and we can expect that in the end of life the failure rate could be far more greater again. End of life region. Why? Because after 10 years, let's say the manufacturer is saying my panel is good for 5 years. My it's good for 5 years. So I usually start my installation from the 5 years. Okay, in the start there could be faults. Okay, because whenever you are going to install a new system, okay, you, of course, devices could be failure rates could be there. Why? Because during the commissioning stage also, when we are doing commissioning, there is usually a failure. Okay, but that failure is very much less as compared to, means there are system failures. So maybe in a 1 or 2 days we may get faults. Okay, sometimes when you are resetting the hardware or our complete panel, okay, sometimes the fault is not quickly identified. Okay, so when we are going in the usually in the installation and commissioning stage, the faults will appear sometimes in a day, in a couple of days. Okay, when the system becomes completely commissioned, everything is programmed. Okay, then it remains consistent. So we check out the region, the statistical region. Okay, now this is the testing region or the used region, okay, where we tend to identify what is the failure rate. Okay, if the failure rate is consistent, it's fine for me, no problem. End of life, this is the end of life region. End of life, of course, the components failure is there. Why? Because the manufacturer is saying that my components will run for 5 years, so resistance will blow, fuses will blow, capacitance will blow. Okay, so in the end of life, the failure rate will always be very high. Okay, so this is a type of a path. That is the bathtub curve. Okay, to identify the lifetime curves, as I said, we usually calculate it 3% per year. End of 4 years, 12% of faults is going to be there. Okay, so based on that, we need to see that how many hardwares are being repaired then required for each fault, a single hardware, or each fault 2 or 3 hardwares. So based on that, we tend to make this curve. So in the testing region or in the failure region, let's say that if the fault ratio is again increasing high, fluctuating, consistent, fluctuating, consistent, means reaching above even the end of life region. Means end of life, I know that there could be component failure. Maybe I may require to replace the system, okay, or I may require to replace the whole control panel. But before the end of life region, if there is a fluctuation in the bathtub curve, it gives me an idea that there is going to be a specific hectic amount in the afterwards. So for that purpose, I need to know the bathtub curve for the system that provides me the failure rate of the system itself. I hope it's clear now. It's clear. Usually, let's say, like if I want to say, like for example, when I'm purchasing a car, okay, so usually I say that what is the devaluation value of the car. So like for example, if I have any type of a car, so if the car devaluation value is 5% per year, so it means by the end of the 5 years, 25% of the value of the car will be lost. So it means that car is not going to be useful for me, right? So means if I'm going to resell it, 25% of the value of the car has been devaluated. So it means that car is not going to provide me any type of benefit. Similarly, it goes for the fire alarm systems. Similar situation in which we tend to identify the number of faults per year, how much investment we have to do it per year. So usually the manufacturer does not provide 5 years. They usually provide 1 year of maintenance. Okay. 1 year of component failure they usually provide, because if they provide long term, it's not beneficial for them. And electrical components, they tend to get short. It's usually a part, because there could be any type of transient signals coming from AC or DC that can affect the electrical components. So for that purpose, we usually make the bathtub curve. We request a bathtub curve from the manufacturer also, and they also can provide you based on their previous projects, previous installation. Okay, this is the last project. Okay, we have made this one. Okay, from a specific company, the facilities management, they requested it. We have made it based on our visits and based on the year of installation that we have done, like 10 years. And this is the number of visits that we have made is approximately 2. Okay, so they tend to identify, okay, yeah, it means that means the failure rate is very less. So like this, they can also represent, and we can also make it our own. The facilities management usually make it to identify that what is the failure rate of this component, whether we are going to use the same product for other projects or not. Okay, so usually the bathtub curve provides us the failure rates with the passage of time. It's going on, and it goes through the end of life region. Yeah. But we have discussed this one just for the information, but this is not part of the CFPS examination. Okay, this topic is not part of the CFPS examination. It's just because you requested it, so I just provide you a brief discussion on this one. Yeah. Okay, let's just take some sample questions from this section. Oh, sorry. Okay. 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 Wait. Just a second, guys. Just a second. Hold on. Okay. Ah. Just a second, please. I think so some vision is here. Okay, sorry guys, let's start. Okay, yeah. Okay, question number one. Let's start. Okay, okay. The system that provides interface between a protected premises fire alarm system and a public fire reporting system is defined as. We have got answers. Okay, let's see. Okay, one is D. Okay, anyone else? Everyone go for D? Yes, we have discussed in the fire alarm systems types. Okay, the system that provides an interface between a protected premises fire alarm system and a public fire reporting system. Okay, means that an alarm signal is between the occupancy, okay, and directly towards the civil defense public fire reporting, that is auxiliary system, that is D. Okay, heat detectors. Question number two. Heat detectors are the oldest type of automatic fire detection device. They began with the development of sprinkler systems in year. Yes. 1860s. Yes, 1860s. Just remember that this type of questions are actually NFPA. Okay, they're specifically especially in the CFPA. So they tend to bring up this type of questions. Usually, we are expecting heat detectors. They may ask. They are convective devices. They may ask. They are or sprinklers. They are thermosensitive devices. They may ask that also. But usually, our focus is there, and they tend to bring questions like this from the history. Okay, so yes, the right answer is 1860s. Okay, heat detectors and the sprinkler systems, they both came, okay, in production in 1860s because they both are considered as convective devices because their heat transfer mechanism is convection. So that is why they usually, yes, 1860s. Okay, then eutectic metals, okay, that melt rapidly at a predetermined temperature corresponds to which heat detection type? Yes. Eutectic metals, yes, that melt rapidly. That melt rapidly, yes, at a predetermined temperature corresponds to which heat detection type? Yes, it is fusible element type. Exactly. The right answer is fusible element type, option B. Okay. NFPA 72 requires any heat detector combined with smoke detector, okay, should have a listed spacing of. Okay, we have an option A. Anyone else? Heat detector combined with smoke detector, yes, should have a listed spacing of, yes, 50 feet, that is 15.25 meters. Yes, exactly, it is 50 feet. Next question, carbon containing fuels emit significant radiation in 4.35 micrometer band can be detected by 4.35 micrometer band can be detected by. Okay, we got to see. Anyone else? Significant radiation in 4.35 micrometer band. So we have discussed about the radiations of ultraviolet and bandwidth radiations, right? In which we discussed that the ultraviolet radiation is 0.10 to 0.35 micrometers, right? So, and infrared radiations we discussed were for 0.76 to 220 micrometers. So 4.35 micrometer comes in the bandwidth of infrared radiations, right? So it means any carbon containing fuel that emits significant radiation in 4.35 micrometer can be detected by IR detectors. Option C, right, is the right answer, okay? A signal that indicates a fault in a monitored circuit is stated as? Yes, a signal that indicates a fault in a monitored circuit is stated as a fault alarm. And the second name, they can use it as a trouble alarm. Okay, so it is a fault or trouble alarm. Okay. Next question, secondary power supply for a fire alarm system is required to supply the energy to the system within. Yes, it is within 30 seconds of disconnection. Exactly. Within 30 seconds of disconnection, okay, because the secondary power is not only the batteries, it could be a generator set also, considering the secondary power. The circuits in which two-way communication takes place is signaling line circuits, yes, in which we tend to communicate with the panel and the panel communicates with us, okay? So any type of communication that takes place with the panel or the panel with the user, okay? So that type of a circuit is a signaling line circuit, okay? Yes. Heat detector has the lowest false alarm rates of all the automatic detection devices. Oh, sorry. Yeah, oh, I gave the answer. Okay, the detector that has the lowest false alarm rate, that is the heat detectors. Yes, exactly. Heat detectors has the lowest false alarm rates of all the automatic detection devices. Exactly. Yeah. Okay, the detector. Next question. The detector that corresponds to low thermal lag. Okay, we have two options: rate of rise and rate of compensation. So the detector with low thermal lag. Yes, the detector with the lowest thermal lag feature is rate of compensation detectors, right? These are the detectors that has the lowest false alarm rates, lowest thermal lag. Okay, rate of rise and fixed temperature has more high thermal lag features, meaning that any temperature differential is going to get them activated. Okay. The protection goal embraces a combination of three primary goals, excluding insurance protection. Okay, excluding insurance protection. Exactly. Fire alarm system installation, maintenance, and use are specified in. It is A, NFPA 72. Exactly. Emergency voice alarm communication system must have 24 hours of standby power, followed by emergency operation of. Yes. Emergency operation of B, 2 hours. Exactly. Okay. All other systems They require 24 hours of standby power, followed by 5 minutes of alarm. Okay. Emergency voice and alarm communication system requires 2 hours of emergency operations. Okay. A two-wire circuit configuration that operates up to a single fault is labeled as, yes, we have A. Anyone else? B. Class B circuits. Yes. That's a draw. Anyone else who wants to contribute? A two-wire circuit configuration that operates up to a single fault. You'll find this answer in detection and alarm in the section 14, chapter 1. You will find this answer. In the start we discuss when we if we are talking about a lecture, so in the start we discuss about in the section chapter 1, section 14, chapter 1, this information is available. And if you remember, we discuss about in the lectures we discussed in the conventional system and addressable systems, right? And you will find out the circuit two-wire circuit configuration, okay, that operates up to a single fault. Okay, as per NEC it is a class B circuit. Exactly. Okay, so the reference is also being provided. Page 14. Say, page means section 14 and page number is 6. Okay, so section 14, page 6, you will find the answer. Okay, it's class B circuit. Okay, class A circuit is a parallel circuit which does not affect the whole circuit. Okay, it only affects the device. Okay. Question 15. In protected premises system, the alarm is, among these, which statement is true? Okay, we have A. B. In protected premises system, yes, uh, there is one thing is true, that alarm is not related to the fire department. This statement is actually true. In the protected premises system, if you remember, we said that the alarm remains within the building, okay, and only the security or the watchman is the one who tends to see the alarm. And if he wants, and if he feels that there is any type of emergency or it requires assistance, then only he can refer towards the civil defense, right? So yes, the statement that it is not related to the fire department. So the right answer is A. NFPA 72 states that only fire alarm signals may be transmitted to fire department by an 'okay. We have got two options of A. Yes, the fire alarm signals, okay, may be transmitted to fire department by an auxiliary system. Yeah. The right answer is A. Number 17, the fire signatures most used as basis for detection are heat, smoke, and yes, exactly, it's the radiant energy and radiant energy. Okay. In fusible element type, the eutectic metals contains alloys. The excluded one is excluded one. Okay. Uh, yes. What are the eutectic metals? Eutectic metals, the combination of metals that provide the lowest melting point. Four metals, okay, bismuth, tin, lead, and cadmium. So the excluded one here is nickel. Nickel is not an eutectic metal alloy. Okay. So yes, the right answer is C. Question number 19. Okay, the low expansion metal commonly used in war, an alloy that contains nickel of percentage. Okay, 36% is nickel, and the remaining is what? Right answer is 36%. The remaining is iron. Exactly. Remaining 64% is iron. 36% is nickel. Okay. Photoelectric smoke detectors as a class provide superior response to. Okay, we got an option A. Yes. Photoelectric smoke detectors, they provide a superior response to low energy fires. Okay. They usually require, they provide superior response to low energy fires. Okay. So these were some sample questions, okay, from section 14, but it's not I mean, we have, it's totally all and all covered up. No, they a lot of more questions can be made out of it. Okay, but these are some of the questions that have been repeated in the that have appeared in the previous exams. Okay, like a lot of questions can be there. Means like someone can ask you about the NFPA evacuation signal, carbon monoxide evacuation signal. They can ask you about the stop light intensity. They can ask you about notification appliances intensity. And we will see these questions in the mock also in the last, when we'll be discussing about 70 questions in the last. Okay, so we will see these questions there also. We will discuss these questions there. Okay, so but anyways, these were some of the questions just for practice, just to analyze that how much understanding do we have of the section. Okay, so this was from the section 14 of the Fire Protection Handbook. The next section that we are going to move on will be section 17 of the Fire Protection Handbook. Okay, and that is fire extinguishers or portable extinguishers. Okay, so we'll discuss about this section. We'll see what are the fire extinguishers, different type of extinguishers we are going to discuss here. Okay, chapter 4. Just a second. I like this chapters actually. Um, the interconnected systems, right? Fire alarm interconnections. Okay, fire alarm interconnections with the sprinkler systems and with this. We will discuss in section 16, because this section, section 14, chapter 4, fire alarm system interconnection. Okay, like elevator connections. Okay, and then we have the automatic sprinklers like zone control valves, OS and Y gate valves, and any type of fire pump alarms. Okay, so we will combine with section 16. Okay, in the CFPS blueprint. Okay, when we'll be discussing, when you'll go towards the section 16, there they have mentioned interconnections. Okay, so we'll discuss the interconnections there about sprinkler systems. First, we'll discuss about the sprinkler systems. What are the types of systems? Wet system, dry system, deluge, pre-action. Then there we are going to discuss the interconnection there. Now, these systems, because now if I'm going to discuss the system, the maximum discussion will be up to zone control valve. But we have to discuss about the pressure differential valve. We have to discuss about the air pressures in the dry pipe systems. Then we need to discuss about the ultra high speed water spray systems, in which we, again, the detectors will be integrated with the fire alarm systems. Then we have to discuss about the inter-deluge systems, how the system they tend to operate. Pre-action system in a two-stage operation, where a detector is the first stage operation from the fire alarm control panel. Water enters into the system. Sprinkler is the second stage operation. So there the interconnections will be discussed in more details. Okay. So we will cover this section in section 16. Okay. Yeah, where we are going to discuss about this about the interconnections of the system, of the sprinkler systems. Okay, and the blueprint also in the section 16 only, where they have described the water-based suppression system. 20% of the age of the examination, they have kept this as a syllabus, where they have discussed about the interconnections of a fire alarm system. Okay, so we will combine it there, and then we will discuss in complete detail. We'll go, after section 17, completing section 17, we'll go for section 16. Okay, so in the section, that's why we are keeping like all this in chain. Okay, we don't want to go towards the theoretical portion. The basics of fire and science, we have discussed about the theory of detection and extinguishment. That is why we're going for section 14 and 17. Then sprinkler systems. In the sprinkler systems, again, they are all interconnected with section 14 and 16, 14 and 17. You will see when we'll be discussing about the section 16 sprinkler systems, the topics will be somehow related towards section 14 and it will be related towards section 17 also. Okay, so there will be some combined topics. That is why we are going from section 2, 14, 17, 16. Okay, like this. Okay, so this will be covered there also. Okay, any questions from this section 14? If you have any questions regarding this section, because before moving on section 17, okay, if you have anything in section 14. Okay, so let's move on towards section 17 of the Fire Protection Handbook, extinguishers, in which we are going to discuss about fire extinguishers. And fire extinguishers means not necessarily all the fire extinguishers, meaning like usually the name is fire suppression without water, but we have foam systems there which have water as an extinguishing. So not we cannot simply say that it's going to be a completely water-based fire suppression without water. Anyways, it is going to be different types of extinguishers that we are going to discuss, the limitations of these extinguishers, okay, and the use of those extinguishers. Like for example, we'll be discussing about the carbon dioxide systems, its properties, extinguishing characteristics, okay, how it can be applied, what are the limitations of carbon dioxide systems. Then we'll move on towards the dry chemical powders, okay. Dry chemical powders, they are very they can be considered to be using all the four extinguishing mechanisms, or we tend to say the tetrahedron of the fire triangle. Fire is actually accomplished by the uh, by the DCPs, dry chemical powders. Okay, so dry chemical powders. So what are their limitations? Okay, what are the base chemicals? Okay, and which base chemical is known as a multi-purpose dry chemical? Then we will move on towards the wet chemicals, okay, usually used in class K fires, cooking oil fires. We'll see about the base chemicals, their characteristics, what is the process of saponification, how it can be achieved. After completing that discussion, we'll move on towards the dry powders, okay. Dry powders, they are different than dry chemical powders. Dry chemical powders are meant to be used on class A, B, and C fires, while on the other hand, dry powders, they can be used on class D fires. Okay, we will discuss about that also. Eventually, in the last, we'll be moving on towards the form systems, in which we are going to discuss about different types of forms, what are the extinguishing properties of the forms, how they are useful on class B fires, okay, and what are their limitations. Similarly, then we'll move on towards the last topic, that will be the clean agents. And the clean agents, we'll discuss about the compounds and inert gases, what are their combination, okay, and some of the characteristics of the compounds, okay, why the compounds are all in all they are very effective, but they cannot be used, why they're environmentally dangerous, okay, and based on that, why we want to use inert gases, okay. So we'll discuss all this in the section 17 of the Fire Protection Handbook for the CFS examination. Starting our discussion, we'll continue from carbon dioxide extinguishers, CO2 extinguishers. Okay. Starting our discussion from carbon dioxide systems. Okay. Okay. Carbon dioxide systems, okay, are the most, you can say, all type of systems that we have been using. And why we tend to use is because there are some very important or good properties of carbon dioxide system. Okay. First of all is that a limited amount of carbon dioxide system is not dangerous for the human being. Regardless of the fact if I'm going to use it as a total operating system, means as a complete occupancy uh, occurrence of carbon dioxide, it removes the oxygen very effectively. So yes, it is usually whenever we are going to use carbon dioxide system as a standpipe system, okay, it will be only used in occupancies in unmanned areas. Okay, we don't want to use them in manned areas where we have people available, because it removes oxygen very effectively. And that is the prime purpose of the carbon dioxide. The prime purpose of extinguishment is also the removal of oxygen. Okay. The secondary purpose is the cooling effect that it tends to provide. Okay. So we'll discuss from the carbon dioxide systems, and we'll see that what are the properties, features of the carbon dioxide systems. And then slowly and gradually we'll move on towards the other extinguishers. So let's start from carbon dioxide systems. Yeah. Ow. Oh, yeah. Sorry. Carbon dioxide systems, again, the first important thing about a carbon dioxide system is that it has been used, okay, for nearly 100 years, more than 100 years even, more than 100 years. And the first system was installed in Europe, okay, in 1910 to 1915. The first system was installed in Europe, okay, between 1910 and 1915 in Europe. Okay, carbon dioxide system is very effective in providing extinguishment because it serves two very important purposes. The prime purpose of carbon dioxide system is oxygen removal. Okay, and the secondary purpose, this is the prime purpose, prime extinguishment. The secondary purpose of carbon dioxide is cooling effect or absorbs heat. And when I'm saying cooling effect, okay, means the carbon dioxide is a cold gas and it tends to absorb heat. Okay, that is the prime purpose and secondary purpose. The prime purpose, the major purpose why we use carbon dioxide is removal of oxygen. It removes oxygen from the fire and it extinguishes the fire. Secondary effect can be even defined that carbon dioxide occurs in forms of solid, liquid, and gaseous form. Okay. Solid form of carbon dioxide occurs at a temperature of minus 79 degrees Celsius. I'm giving the values in Celsius. Okay. In the examination, the values will be in both Celsius and Fahrenheit. For me, Celsius values are more easily. I mean, I can remember values. I can understand the values in Celsius. Okay. So I usually use the value Celsius, but don't worry. In the examination, both values will be given in the answers. Okay. Celsius and Fahrenheit both will be given. Liquid form of carbon dioxide is at minus 18 degrees Celsius. Okay. And the gaseous form or the vapor form of carbon dioxide occurs at 36 degrees Celsius. Gaseous form, 31 degrees Celsius, sorry. Yes, 31 degrees Celsius. Okay. Solid form of carbon dioxide is also known as dry ice. Okay. Solid form of carbon dioxide is also known as dry ice. Carbon dioxide has one feature, okay, like other gases also. Carbon dioxide occurs at triple point, okay. And what is the triple point? The triple point temperature is the temperature of a carbon dioxide. Okay, triple point temperature and pressure. We cannot measure temperature without a pressure, right? We have discussed this in basics of ion science. That atmospheric pressure remains 101.3 kilopascal as a constant, right? But at a specific pressure and temperature, carbon dioxide occurs in all three forms in equilibrium with each other. Meaning, at same temperature and pressure, it is in solid, liquid, and gaseous form in all three forms at one temperature, and the concentration is also same in equilibrium. That's why I was saying equilibrium. Okay, in equilibrium with each other means the concentration of the carbon dioxide remains same in solid, liquid, and gaseous forms, but the form is different. That is called a triple point for form of carbon dioxide. So triple point form of carbon dioxide occurs at minus 57 degrees Celsius, okay, at a pressure of 75 psi. Okay, so this is the triple point temperature. Temperature and pressure of carbon dioxide. Meaning at a specific temperature of minus 57 degrees Celsius and a pressure of 75 psi, okay, carbon dioxide occurs in all three forms. Okay, it is solid, it is liquid, and gas in all three forms in equilibrium with each other. Okay, it is in all three forms. Okay, carbon dioxide extinguisher. Why do we have to wait for the carbon dioxide to be, I mean, all three forms? What is the feature of that? We will discuss that. Why the triple point temperature and pressure is important. Okay, we will discuss that later on. Okay, but anyways, okay, the carbon dioxide is usually in a standpipe system. The carbon dioxide is usually discharged from nozzles, right? It's usually discharged from nozzles. Okay, and whenever it is discharged from nozzles, what happens? That it has the capability of carrying static charges on the partial point of the nozzle. Okay, usually whenever the carbon dioxide discharges at a very high pressure, okay, in a standpipe system, what happens? Whenever it's discharged at a high pressure, what happens? The static charges tend to accumulate here. And if any person who tends to hold the conductive part, he may find a shock hazard. So for that purpose, NFPA2 recommends that all the nozzles should be grounded. Okay, all the nozzles, they must be grounded. Okay, so that the static charges are always neutralized. When we are talking about the nozzles of the carbon dioxide system can be categorized into two types. Okay, these nozzles, okay, depend upon the capability of the carbon dioxide, how we want to deliver the carbon dioxide in a specific environment. Okay, like I mean, what is the pressure, what is the type concentration of carbon dioxide, what is the property of the carbon dioxide that we want to achieve. Nozzles can be categorized into two types. Okay, these nozzles can be high velocity nozzles, okay, or they can be categorized as low velocity nozzles. Okay, either they are high velocity or low velocity nozzles. And when I'm talking about low velocity nozzles, okay, so it means that the nozzles will have much more larger orifice. When I'm talking about high velocity nozzles, so usually the nozzles will have less orifices, means the exit point will be, discharge point is going to be very less. Okay, so I use high velocity nozzles where I want the carbon dioxide to be delivered farther in an area. Low velocity nozzles are used where the carbon dioxide does not require to be delivered. The system is installed in a small area. Okay, and when I have large area, so I want the gas to be discharged at such pressure that it delivers at the far end of the occupancy. So low velocity nozzles usually are where I want where the area is small, I want carbon dioxide just to be discharged, okay, to cover up the small area. So usually in the examination they ask a question, okay, that carbon dioxide system concentration, like carbon dioxide concentration will be high in which type of nozzles? Carbon dioxide concentration will be high in which nozzles? High velocity or low velocity nozzles? Yes. Higher concentration of carbon dioxide. In low velocity nozzles, exactly. Why? Because the distance it has to travel less distance. The more distance the gas has to travel, the more air air will be used as a medium. So more dilution is there. So less concentration of carbon dioxide is always expected. Okay. So usually we have nozzles of two capabilities, high velocity and low velocity nozzles for the carbon dioxide systems. Okay. Whenever a carbon dioxide system is applied in an area, what happens is that it removes oxygen, we have discussed, right? But what is the percentage of carbon dioxide that is much more dangerous for us? Okay. So carbon dioxide in specific areas hold a specific percentage. For example, carbon dioxide in atmosphere, considering 6 to 7% of carbon dioxide is the threshold, safety threshold. Meaning 6 to 7% of the carbon dioxide is reaching the threshold, and above the threshold it's going to be very dangerous. Okay. Then we have 9%. Above 9% of carbon dioxide available in the atmosphere, what it tends to do, it tends to give like unconsciousness. Okay. Narcotic effect. 17 to 30% of carbon dioxide can lead towards stop of breathing. So that is why whenever a carbon dioxide system is installed, okay, two considerations are made. Before the activation of the system, okay, it is made sure that the carbon dioxide system, okay, whenever it's going to discharge the gas, there is a timer, okay, so that the people can evacuate. The doors are closed, sealed, and then the carbon dioxide is released. Okay, so why? Because any person in that area cannot survive up to that level. So carbon dioxide has specific threshold level. So in the examination, they can ask you that a narcotic effect or unconsciousness can start taking place. Okay, at which percentage? Okay, where the harmful effect becomes noticeable in human being is 9%. Okay, 17 to 30%. Okay, usually concentration is so much high that unconsciousness and stops breathing immediately. Okay, so 17 to 30% can be considered to be that one. So if enough supply of oxygen is not available, then breathing stops immediately. Okay, so that is how harmful the carbon dioxide is for the human beings. Okay, so what are the method of application that we can use carbon dioxide to apply for? Carbon dioxide can be applied by two methods. Okay, one type of a method for application is known as a local application system. And the second type of a method is a total flooding system. What is the local application system? In a local application system, what we tend to do, we have any type of a material that is available, and the nozzle is placed directly on the material itself. Okay. If a fire appears, what will it will do? The gas will release directly on the material, regardless of what is happening in the environment around it. Okay. The carbon dioxide will be released directly on the material itself. Okay, so that is a local application system. Like for example, if I want to give you an example, the portable extinguisher is a type of a local application system. The portable extinguisher we tend to apply. Okay, the hose is placed directly on the top of the fire. We apply carbon dioxide, it goes there and provides a contact point extinguishment. So local application is providing a contact point, means nozzles are brought up by the pipings and directly on the top of the material. If fire appears, the carbon dioxide on the top of the material will be applied. Okay. Then comes the total flooding system. In the total flooding system, usually we have a closed compartment, okay, and we have fixed nozzles placed. And the purpose is that once the system gets activated, usually a sounder or a hooter starts, and what happens that carbon dioxide is completely occupied the whole room. In the total flooding system, we usually say the holding time of the gas is there. For how long the gas will hold, 5 to 7 minutes, okay, 10 to 15 minutes, okay, depending upon the concentration of the gas. And but what happens in a total flooding, the whole room is occupied with the gas. And once you have to make the system normalize and after the fire is extinguished, okay, so what happens is that the area is ventilated, carbon dioxide is removed, opened, oxygen allowed inside, and then the people can come back into the area. Otherwise, the total flooding system is much more dangerous if usually installed for unmanned areas in turbine enclosures. Engine rooms. Whenever there's a fire or a person finds out a fire, he can actuate a system and he can simply exit the area. So the doors will close, locked, sealed, and then the carbon dioxide will be released in that area. Okay. On which fires carbon dioxide is effective? Carbon dioxide is effective on which fires? Carbon dioxide is very effective on class C fires, means electrical fires. Okay. And why it is effective on electrical fires? Because the carbon dioxide has very good feature availability. One of the best properties of carbon dioxide is that it leaves no residue. So it can be easily applied on electrical fires because it leaves no residue. It has some effect on class A fires, okay, but it has a limited effect, okay, because it does not have that much cooling capacity. The carbon dioxide, whenever it's released, okay, so it absorbs heat up to a certain limit, but in the atmosphere, it leaves no residue, it vaporizes very quickly. So that is why it has very less cooling effect. So on class A fires, if I'm going to apply carbon dioxide, it will extinguish the fire, but it will not provide a cooling effect. The cooling effect is very important because it cools down the material itself. If the material is not cooled down and it's heated up, again a fire, reignition is a possibility that can appear. That is why the on class A materials, it has a limited extinguishment property, but very effective on electrical fires. Okay. When we're talking about effectiveness on class C fires, what are the limitations of carbon dioxide? Carbon dioxide has limitations, okay, on any type of materials that have their own oxygen supply, okay, that any chemicals that have their own oxygen supply, like cellulose nitrates, okay, nitrates, nitrites, sulfates, okay, chlorates, carbon dioxide is ineffective, okay, any chemical that has its own oxygen. So, okay, let's talk about the limitations. Any chemicals with own oxygen supply. Next, okay, any type of reactive metals like uh, magnesium, potassium, zirconium, titanium, sodium, okay, so these reactive metals, carbon dioxide is ineffective. Fires involving reactive metal. And any type of metal hydrates, okay, carbon dioxide can be ineffective because their temperature increases. Okay. So these are the limitations of carbon dioxide. Carbon dioxide cannot be applied on all type of fires. Okay. Then let's see what are the storage practices of the carbon dioxide. Storage containers. Carbon dioxide can be stored in the containers. Okay. Two types of containers are there. One are the low pressure storage containers. In low pressure storage, the pressure that we need to maintain is at least 325 psi. At least 325 psi. Okay. In high pressure containers, okay, or large pressure containers, okay, large storage containers or high storage containers, okay, there's no pressure limitation. The pressure limitation or the temperature limitation depends upon the quantity of carbon dioxide stored. Depends upon the quantity of carbon dioxide that is being stored. That is the high storage containers, okay. High pressure storage containers, okay, big vessels, okay. There no pressure limitation because we don't know what quantity of carbon dioxide we are storing, and based on the quantity of carbon dioxide that we are storing, okay, we have to make sure what is the based on the quantity we have to make sure what is the temperature and pressure that we have to maintain for carbon dioxide. Okay. So in the design perspective, usually the carbon dioxide is designed in method of application. We have discussed total flooding and local application. In the total flooding system or a local application system, these both are standpipe systems, right? A type can be installed as standpipe systems. In the standpipe systems, one thing is very important. That is the pressure of carbon dioxide in the pipeline, okay? The pipeline pressure must be kept well below 75 psia. Okay. Why it should be well below 75 psi? Anyone?
Is it because of the triple point?
Triple point pressure, yes. The triple point pressure is of 75 psi. We have discussed the triple point pressure here. Okay. It means what will happen? The carbon dioxide will form into a solid form within the piping, which will block the orifices. It will convert to dry ice within the piping. It will block the orifices, block the nozzles, no carbon dioxide flowing. And it will damage also the piping. So that is why whenever standpipe system of a local application or total flooding is being designed, okay, the pipeline pressure should be kept, must be well below 75 psi. Exactly. So we have to make sure that any type of piping, the pressure should be well below 75 psi. Okay. So NFPA12, okay, required for the carbon dioxide system. Whenever a newly system is installed, a full discharge test is usually required. So NFPA12 requires a full discharge test for a newly installed system. So usually in the carbon dioxide systems, whenever we have systems for a complete total flooding system for a complete occupancy, we usually have cylinders that are available in line with each other, like 4 or 5 cylinders, depending upon the quantity of carbon dioxide to occupy the whole room. And they all are monitored by a single actuator. And this single actuator, what it tends to do, it triggers uh, the whole pins of the cylinder, allowing the gas to travel from the piping directly towards the occupancy. So when we are talking about a total flooding system of so NFPA12 requires a full discharge test. Full discharge test gives us two very important parameters of the gas itself, also especially for the carbon dioxide. First of all, the actuation mechanism, whether your newly installed system is actuating properly or not. Okay. Then the activation time. Okay, actuation mechanism is being provided. So in how much time the gas reaches the nozzle, okay, and into the occupancy, into the protected area. Second thing that is very important is the holding time of the gas, whether the concentration and the holding time of the gas is appropriate or not. Okay, so you can check that also. So if the holding time is less, it means the gas is less concentrated. If the holding time is more, means the gas is much more concentrated. Okay, so from the holding time, based on the manufacturer's requirements, on the consultancy's requirement, that how much holding time do we require for a specific requirement, and holding time is also calculated by the amount of combustibles that are available within the environment. Some combustibles may be like ordinary combustibles, okay, they may not require that much amount of concentration of carbon dioxide. They may merely require only a removal of oxygen, okay, to extinguish and cool down. So it may require to have a holding time less than 5 minutes, okay. 2 to 3 minutes holding time sometimes is enough. But sometimes what happens that your like turbine enclosures, okay, uh, any type of electrical rotary machinery rooms, okay, so there the temperature is usually very high, so there you may require more concentration of carbon dioxide, so the holding time will also increase accordingly. Okay, so the vapor air dilution is not affected that much based on the amount of combustibles that we are storing. So based on that, we have to identify that what will be the holding time of the gas. So that is why NFPA2 requires a full discharge test of a newly installed systems. And so usually this full discharge test is usually done for the total flooding hazards, okay, to see the concentration of the carbon dioxide, first of all, and then to see the holding time in the fire zone. And why do we require the holding time? That it totally depends upon the combustibles that are available there. Okay. Okay, so this is all for the carbon dioxide systems. All operating devices in the maintenance, okay, all operating devices should be tested annually. Okay, usually we do the quarterly inspection of the carbon dioxide systems of the portable extinguishers. We usually do quarterly, okay, like after every 3 months we usually do check the carbon dioxide extinguishers in the portable ones. Okay, standpipe systems, depending upon the occupancy's requirements, okay, it can be semi-annually or it can be annually, but semi-annually or annually also depends upon the installation requirements that have been already completed within a facility. Sometimes what happens that we have too much toxic vapors in an environment. Okay, so for that purpose, we may schedule the maintenance much more earlier also. Okay, but we can have devices that can be tested, that can be checked, okay, that can be replaced, okay. And during the maintenance, sometimes you may require a couple of only extinguisher, a partial discharge may be required, okay, to see the operation principle of the carbon dioxide, whether there is any type of a leakages in the piping, okay, because of the toxic vapors. Any actuation assembly is not operating, so you have to test that also. You have to test the hangers and braces for the pipings. So for that purpose, you may require a partial discharge test also, but it should be done annually. Okay, so any type of correction that is being found, any type of maintenance that is being found during the inspection, it requires to be replaced as soon as possible. Okay. So this is for the carbon dioxide systems. Why do we require, how do we check a portable extinguisher of a carbon dioxide? And in which form carbon dioxide is stored in a portable extinguisher? Okay, just a second. There's some questions also.
Liquid form.
It's in a liquid form, right? We have discussed this. It is in the liquid form, right? That is why we check the weight of the carbon dioxide. Okay, that is why the weight of the carbon dioxide is always checked in the portable extinguishers. And if the weight is less, but the weight also does not give us a confirmation. One information that you should always have, the weight itself also sometimes does not give us a confirmation that a carbon dioxide is in a good form, because if the carbon dioxide has already converted to a solid form, okay, so we may get a weight approximately equal to 5 kg only. Okay, so in that cases also there is usually you have to like slightly you have to tilt the cylinder to see if you can hear any hard crystals, sounds coming from the cylinder, so you can identify that the carbon dioxide is already converted to solid form. So in case of any emergency, it's not going to give us any carbon dioxide from the hose. So for that purpose, carbon dioxide extinguishers are very difficult to maintain. Difficult to maintain in a sense that it is difficult to see that which form carbon dioxide is available, because it occurs in the triple point form based on the temperature variation. So we don't know how the carbon dioxide is being delivered to us. Okay, usually when the carbon dioxide is imported, okay, so we don't know in which form, in which environment it has gone through, and the only way to check out is a partial discharge. But once as an extinguisher, portable extinguisher is activated, So you have to completely refill the extinguisher of the carbon dioxide, because the carbon dioxide starts converting quickly to a solid form during a single activation. So for that purpose, the carbon dioxide extinguishers, they are very difficult to maintain. Effectiveness is that they are very useful on electrical fires, because electrical fires, okay, we usually want a extinguishment, and we don't want any type of residue left over. Residues, okay, whenever they're left over, they damage the whole PCBs, the whole electrical component, which may be quite costly. Okay, so for that purpose, the carbon dioxide extinguishers are very effective on electronic equipment. Okay, last section. No. We have some questions. Okay, can you repeat the test and maintenance points, please? Okay. Testing and maintenance of the carbon dioxide. A carbon dioxide fully a total flooding system, okay, should go through a full discharge test. Full discharge test means that when a newly system is installed, okay, you have installed a new system, and as I said, that checking of the carbon dioxide system is very difficult. Means we cannot maintaining a carbon dioxide portable extinguisher also very difficult. So similarly, the same goes for the total flooding system also. So whenever we have a carbon dioxide newly system installed, we want to actually see whether the carbon dioxide actuation assemblies, everything is fine, whether the gas is reaching towards the nozzle. Okay, so in that full discharge test, we are going to check two things. Okay, first will be the concentration of carbon dioxide, okay, and the holding time of the gas. So when a full discharge test is done, so we also check whether the pipeline pressure is also designed effectively, so that the piping is not blocked. Okay, that is also tested. So that is why when a new system is installed, a full discharge test should be done. Means that completely all cylinders should be discharged to see the concentration of carbon dioxide, and as well as the holding time of the gas. The holding time of the gas, meaning that more the concentration of the gas, the more holding time, because vapor air dilution will always be there. Carbon dioxide, whenever it comes out, okay, and you have atmospheric oxygen and nitrogen also available, so what will happen? It will dilute the concentration of carbon dioxide. So that is why you tend to seal out the whole room. Total flooding means the whole room is completely sealed out, and then the carbon dioxide is exhaust from the nozzle itself. The holding time of the gas means for how long the gas is going to remain in that room. Okay, that is the holding time of the gas. It defines whether the gas is going to be very effective, okay, for some type of combustibles that are available. Sometimes we have less combustible material, sometimes we have more combustible materials. Okay, sometimes the material may not be that much heated up, but sometimes the material's heat attenuation and heat propagation is far more greater. So depending upon the amount of combustibles, we need to know that what concentration of carbon dioxide is required, and for how long it is required to stay there inside the room. That is the whole time of the gas itself. So we tend to usually do that, so that we can check the concentration and holding time of the gas in the fire zone. Okay. So other challenges that we have discussed about the testing and maintenance of carbon dioxide are related towards the portable extinguishers. Okay. And portable extinguisher, it's difficult to know that in which form the carbon dioxide is available. But what we want is we want that the white cloudy appearance of the carbon dioxide to appear directly outside of the nozzle, so that it can extinguish the fires more effectively. Yeah. Okay, so this is for the carbon dioxide systems. Then we'll important points for the examination. They usually ask about the triple point pressure, temperature. Okay, then they can ask you about a concentration of the carbon dioxide that can be dangerous for the human bodies. Okay, storage container pressure, at least what is the minimum pressure that is required. Okay, limitations of carbon dioxide is very effective. You can ask in the examination, and the concentration of carbon dioxide. Sometimes they go for the history also. Okay, and or they can ask you about the nozzles. All the nozzles must be always grounded for any type of a standpipe system, whether it is a dry pipe system, dry chemical powder, it's a carbon dioxide system, clean agent, any type. Okay. the nozzles must be grounded. Because of the intense pressure, static charges are accumulated on the top of the nozzle. Okay, so for this is for the carbon dioxide system. The next topic that we are going to start will be the dry chemical powders. Okay, and we will see what are the features of the dry chemical powders. Okay, what are the base chemicals. Let's just take 10-15 minutes of break. Then we'll continue with the dry chemical powders. Okay, we'll discuss the base chemicals, their extinguishing properties, their uses and limitations. Okay, and then we'll move on towards the wet chemicals. Let's just take 15 minutes of break. If you have any questions, you can just put it in the text. I will come back and I will respond to those questions. Okay. Okay, guys. I wasn't speaking. Yeah. You can hear now? Okay. 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 Let's continue. Okay. And now we are going to discuss about the dry chemical powders. Okay. Let's see what are the dry chemical powders, how they can be, what are the base chemicals involved. Okay. Dry chemical powders or DCPs. Okay. Basically, we use them for various different type of purposes. Okay. Whether we want to use them for class A, B, or C fires. Okay, and we want to see that what are their properties. Okay, so to understand the characteristics of a dry chemical powders, okay, first of all we need to know what are the base chemicals, and each and every base chemical has its own properties. It has its own temperature, it has its own solubility nature, and based on that we tend to discuss that what are their parameters, how they can be used. So to define the characteristic of a dry chemical powder, first of all we need to know what are the base chemicals of the dry chemical powders. Okay, so the base chemicals include the dry chemical powders. The base chemicals include, first of all, sodium bicarbonate. The second base chemical is potassium bicarbonate. Third base chemical is potassium chloride. Fourth base chemical is monoammonia phosphate. Okay. Sodium bicarbonate, okay, has a decomposition temperature of 60 degrees Celsius. Okay, and it is partly soluble in liquid. Potassium bicarbonate has a decomposition temperature much more greater than sodium bicarbonate. It is twice 120 degrees Celsius. Okay, and it is not soluble in water. Potassium chloride has the highest melting point. Potassium chloride is usually crystals, white color crystals. Okay, so they have the highest melting point among the all dry chemical powders, that is 772 degrees Celsius, and they are completely soluble in water. Then we have the monoammonia phosphate. It has a decomposition temperature of 190 degrees Celsius, and it is slightly soluble in liquid or water. Okay, these are the base chemicals that are usually known as dry chemical powders. Starting from sodium bicarbonate. Now, sodium bicarbonate is 60 degrees Celsius decomposition temperature, and it is partly soluble in water. What two informations that we can extract from here? The first information is that the sodium bicarbonate can handle a temperature up to 60 degrees Celsius. As soon as the temperature is above 60 degrees Celsius, the sodium bicarbonate is already decomposed. So it is not going to be useful. Okay. The second information about the solubility nature gives us information whether the dry chemical is effective on liquids or not. Okay. So it's partly soluble on in water. So what does it indicate? Partly soluble. Can I use it on liquid fires or I cannot use it? Use it on liquid fires. Yes. Partly soluble nature defines me what? Whether I can use it on liquid fires or not. Yes, anyone? Cannot use. Yes, we cannot use. Why? Because if I'm going to apply sodium bicarbonate on the liquid, okay, solubility nature is that it is partly soluble, meaning half portion will be soluble, the other half portion, okay, will be insoluble. So it means that there will be some portion of the liquid that will be still exposed. So the fuel will always remain there. So it means that we cannot use it on the uh, liquids. Similarly, if you move on towards potassium bicarbonate, so potassium bicarbonate indicates that it is at 120 degrees Celsius of decomposition temperature, meaning that up to 120 degrees Celsius, it can handle the decomposition. It can sustain it. Above 120 degrees Celsius, what will happen? It will decompose. And it is not soluble in water. What does not soluble means? Not soluble means that it will remain on the top of the liquid, right? So can I use it on the liquid fires or not? Not soluble. Yes, potassium bicarbonate is not soluble in liquid or in water. So I can use on liquid fires. Yes, I can use. Why? Because it will remain on the top of the liquid. It will provide blanketing, radiation shielding. Okay, it will remain, it will cover up the whole liquid and it will extinguish the fire. So yes, I can use it on the liquid fires. The third type of a dry chemical powder is potassium chloride. That is 772 degrees Celsius. Now, potassium chloride is usually used by the firefighters also. They usually carry in sacks whenever they want to make any type of an opening. Okay. In an occupancy, whenever there is highly flammable occupancy, okay, flame intensity is too much high, and they know that there are survivors inside a facility and they want to make an opening. So they usually use potassium chloride. They spray it on the hard combustible products, okay, other than liquid, okay. They use it on any type of solidify combustible products, okay, and they tend to extinguish the flame there, and then they can create an opening so that they can reach to the survivors. So potassium chloride cannot be used on liquid fires because it is completely soluble, meaning it will dilute its concentration as well as it will dilute the concentration of the fuel also. But the fuel concentration dilution is not effective or is not a concern for us because the fuel remains still there intact with least concentration also, but it's still flammable there. So that is why the potassium chloride cannot be used on liquid fire. Then comes the monoammonium phosphate. Monoammonium phosphate has a decomposition temperature of 190 degrees Celsius, slightly higher than potassium and sodium bicarbonate. Usually, the flame temperature of a healthy flame is 57 degrees Celsius. Flame temperature usually is 57 to 67 degrees Celsius. Okay, so 190 degrees Celsius it has a decomposition. Okay, and it is slightly soluble. Slightly soluble means that a very lower portion, less portion of monoammonia will only be soluble, but the remaining one will always remain on top. So it can be used on liquid fires also. Among these dry chemicals, okay, among these dry chemicals, monoammonia phosphate is the dry chemical that is known as the multi-purpose dry chemical. And why we say it as a multi-purpose dry chemical? Because it can be used on all class A, B, and C fires. Okay. So the type of the extinguisher that we usually have, red color one, DCPs, okay, they are usually monoammonia phosphate, okay, and that's why they are known as multi-purpose dry chemical because they can be used on class A, B, and C fires, regardless of whatever their limitation is, but they can be used on A, B, and C fires. Dry chemical powders have limitation, and the major limitation that includes is their residue that they tend to leave after the application. Okay, so that is why dry chemical powders, they are among the dry chemical powders, monoammonium phosphate is known as the multi-purpose dry chemical. Because it is a dry chemical powder, so it means that they have toxicity also. So dry chemical powders, they have a toxicity of some nature that is available within them. toxicity means that sometimes what happens that whenever the dry chemical powder is applied, okay, the particle size can enter through the nose, or it can have accumulate on the top of the skin. So some people may find it like skin irritation, means scratchiness, okay, and they may have like respiratory irritation also, sneezing, frequent sneezing may also be there whenever they are exposed to these agents. So dry chemical powders, they have toxicity. Then we have the particle size of the dry chemical powders. The particle size is very important to understand. The particle size is from less than 10 microns and can go up to 75 microns. Less than 10 microns and go up to 75 microns. Okay. So less than 10 microns, meaning that it can go from the respiration, okay, and it can still go up to the mucous membrane, okay, and affect the lungs also. So, but the more particle size, the more less chances that it's going to go towards the mucous membrane. The more less particle size, the less particle size means 10 microns and less also. So it can go up to the mucous membrane, okay, and it can affect up to the lungs also. So that is why these chemical powders, they have their limitation, and the limitation is majorly because of the powder itself, the residue that it leaves. Okay, what are the extinguishing properties, okay, of the dry chemical powders? Extinguishing properties of dry chemical powder. It has all the extinguishing properties that we have discussed in the tetrahedron. The first thing is that it has the smothering action. Second, it can absorb a specific amount of heat. So means absorption of heat means cooling action. Three, whenever, okay, what it tends to do, whenever it occupies on the top of the flame, okay, any material, whenever a dry ABC powder is being applied, it covers the whole material. So it does not allow the radiation to go towards the nearby materials. Okay, radiations to go towards the nearby material because the powder completely covers up the whole material. So it has radiation shielding. And number four, it breaks chemical chain reaction. So it has chain breaking reaction. All four properties of extinguishment it has. Okay. Like in carbon dioxide, we were discussing about the removal of oxygen, smothering, and we were discussing about the cooling action. It has only two properties, carbon dioxide. Unlike carbon dioxide, dry chemical powders has all the four properties. It has smothering, cooling, radiation shielding, and chain breaking reaction. It means any type of reactive chemicals, okay, we can apply dry chemical powders effectively, okay, reactive metals, but not on reactive metals, reactive chemicals, okay. And why? Because reactive metals also require chain breaking reaction, but dry chemical powders cannot be applied on reactive metals. Okay, we only apply dry powders on reactive metals because reactive metals are class D fires. Okay, reactive metals, they are class D fires. So class D fires, they require a chain breaking reaction. No doubt about that. They require a chain breaking reaction, class D fires, metal fires. So why we cannot apply dry chemical powders? Anyone who has any idea about it? Reactive metal fires, metals, they require a chain break reaction, and dry chemical powders, they do chain break reaction, but we don't apply dry chemical powders on metal fires. Why? Okay. No issues. You can. We'll move on. We'll discuss. May increase the fire. Uh, no, it may not, because metals, they require chain breaking reaction. Metals, reactive metals. When we are saying we cannot apply carbon dioxide, we cannot apply water. Okay, because we require something that can break a chain reaction, and chain breaking reaction is done by dry chemical powders, and it is also done by dry powders also. But still, we use dry powders. Okay, because dry chemical powders has one limitation. Okay, it is because of shielding. No, it is not because of the shielding. Shielding, dry powders also do the shielding. The dry powder that we have is sodium chloride plus graphite plus phosphorus, G1 powders. We apply on the top of the metals, and they also provide the same radiation shielding. The powder itself covers up. Yes, the metal. The dry powders also do the same thing. They provide radiation shielding. Yes, just one. The temperature may be high. That is exactly the point. Okay, now so you can see here the dry chemical powders, they have a limitation of the temperature. The maximum temperature is 772 degrees Celsius. And when we are talking about the metals, okay, their minimum temperature is 1400 degrees Celsius. Okay, so when you want to apply, so let's say 1200 degrees Celsius, but 1400, 1800 degrees Celsius, and it goes higher and higher. So you can see here, none of the dry chemical powder is going to sustain that much. When you're going to apply it, before even reaching towards that temperature, it's going to get decomposed. Okay, so that is why we don't use dry chemical powders for metal fires. Okay, even though the metal fires require chain break reaction, dry chemical powders, they also provide a chain break reaction, but they provide a chain break reaction up to a decomposition temperature. Above this temperature, okay, they cannot provide any of these properties. Okay, so for that purpose, we use dry powders, and dry powders, when we use, the composition is slightly changed. The composition we tend to use is sodium chloride plus thermoplastic level 1. Either we can use that, or if we want more quantity of, or if we have large quantity of metals, more quantity of metals available, and we want more effective, more you can say more quick extinguishment formation. So then we go for sodium chloride plus G1 powder, meaning using graphite plus phosphorus also with sodium chloride to be applied. So that is dry powders for you. So that is why we don't use dry chemical powders on defires. Okay. We use dry powders for defires because dry powders, they can sustain that much of temperature. They can absorb. Graphite is a very good conductor of heat. Okay, so it can absorb heat. Phosphorus creates moisture, so it does not allow more and more air. It creates vapor, more air moisture around the metal. So it does not allow more and more air to reach towards even the metal powder also. So that is why they can sustain that much amount of temperature. Anyways, or back onto the dry chemical powders. Dry chemical powders, they are base chemicals, and based on the base chemicals, they have their own extinguishing properties. But when we are talking about extinguishing properties, they have their limitations also. Okay, so let's see what are the limitations of dry chemical powders. The limitations, all limitations of the dry chemical powder is all related towards the residue that it's left over. Okay, because the residue is very difficult to remove. So when we are talking about a residue, okay, so the residue cannot be used in textile industries, okay, like where we have carding rooms. If you apply dry chemical powder there, the powder will accumulate on the top of the threading, and it will severely affect the whole product. Okay, so that is why it has limitation in textile industry. Dry chemical powder, whenever it's heated up, okay, it becomes more and more stickier. Okay, whenever it is heated up, it becomes more and more stickier. Okay, so that is why it is not appreciable to be applied on electrical contacts. Okay, any type of electrical contacts, when it's dry chemical powders or relays, on any relays, when dry chemicals are applied, they become heated up, sticky, and this sticky nature of dry chemical powder is very insulative also. So what will happen? It will make all the equipment inoperative. Okay, so it is not applied on relays and electrical contacts. Okay, then The third important thing is that, okay, it is not applied on any complicated machinery parts. Okay, it is not applied on machinery parts. And when we are saying machinery parts, okay, like for example, if I have a generator, okay, or any type of a turbine, it's running, okay, and a flame appears, so dry chemical powder is applied. So but what happens again, when it's heated up, it becomes more sticky in nature, so it will extinguish the fire. But the problem is, after extinguishment of fire, what is going to happen? So after extinguishment of fire, I need to clean the dry chemical from there. So when I want to clean the dry chemical powder from there, okay, it becomes heated up, it becomes sticky in nature. Okay, so it is very difficult for us to remove it. So when we will remove it by scratching, what will happen? The insulation of the machinery will also get damaged. And then there are some complicated parts where the powder will go, which will be very difficult for us to clean from there. Okay, so that is why they have the limitation, and majorly the limitations of the dry chemical powders are all because of the residue that it tends to leave over. Okay. Then let's see how it can be applied, application. Same like the carbon dioxide systems, they can be applied in two ways: local application, total flooding, and total flooding systems. Okay, these are the same applications of the dry chemical powders. Is it corrosive also? Dry chemical powders, they are considered to be non-corrosive, and that is why we say that they are for multiple purpose. They can be installed. Okay, like for example, on sea fires, also electrical fires. Okay, we can use them. They are considered to be not to be corrosive. Okay, but in some conditions, okay, in some conditions, they can become corrosive in nature. So like some specifically when you have a specific vapor environment, okay, you have any type of toxic vapor or any type of corrosive vapor, okay, that is already available, okay, in the environment, okay, any type of corrosive chemical that is available in the environment, and you apply dry chemical powder there, then it can propagate the corrosion. Okay, as a standalone, we don't consider it to be corrosive in nature. Okay, it can be used in any telecom equipment rooms. It can be used in on any electrical fires. Okay, uh, and it's not as a solo. It is not considered to be corrosive in nature. Okay, but whenever there's any type of a corrosive chemical that may be indulged with, so they can be considered to be corrosive. Like for example, dry chemical powders, they cannot be used in conjunction with the aqueous film forming foam agents, AFFF, but they can be used in conjunction with fluoroprotein forming agents, FFP. So like this, some chemicals tend to propagate across in nature, some they don't. So that is why we as a sol they don't, but when it's mixed with any other chemicals, they can actually provide corrosion. Let me share you some slide. Let's share the screen and see some of the photos that will help us in understanding the properties of what we have discussed up till now about the carbon dioxide and dry chemical powders. Just a second. Okay. Okay. So we were discussing about a carbon dioxide system. So this is one of the examples of what a carbon dioxide system, a standpipe system is usually. So we usually have various different types of valves that are available. Control cabinet, you can see release valves. Okay, venting is there. Okay, a manifold system. A manifold system means most of the system, most of the cylinders that are combined with one actuation, okay, valve. So it's a manifold system, the multiple cylinders whenever it is combined together. So one of the examples of what we were discussing. Okay, now this is the triple point temperature that we were discussing about the carbon dioxide at approximately minus 57 degrees Celsius. Okay, and the pressure that we usually say is that at approximately a 75 psi pressure that it usually maintains. So triple point of carbon dioxide is a very important perspective that is going to be explain asked in the examination. They are going to ask the same in the examination. Liquid form of carbon dioxide at minus 18 degrees Celsius. Okay, solid or dry ice form of carbon dioxide, that is minus 78.5, but usually we say minus 79 degrees Celsius. Okay, it completes out to be a dry form of carbon dioxide. And now you can see here, it always wants an unwanted, accumulates unwanted static charges that is available. Okay, and that is why the discharge nozzles must always be grounded. Okay, they always carry a static electricity, so that is why the discharge nozzles must always be grounded. Okay, moving on. Carbon dioxide we have discussed. The white cloudy appearance is because the liquefied carbon dioxide has converted to a solid form. Okay, and that is why we find out white cloudy appearance. It removes oxygen, and this white cloudy appearance can absorb heat, but up to some extent. If the object is still heated up, again reignition can occur. So that is why carbon dioxide has very limited use on class A fires. Yeah. Okay. You can see we were talking about a local application system. So now this is one of the examples of the local application system. Nozzles are placed directly on the machinery, regardless of the whatever is happening around. It's an open area. So the carbon dioxide is directly just sprayed on the top of the machinery itself. So that is a type of a local application system. Yeah. So low pressure storage containers, okay, where the pressure should be maintained at least 325 psi. High pressure containers, we have to make sure what is the quantity of the carbon dioxide that is available with us. Piping, okay. So this piping system that we were discussing, and then we have the nozzle heads. Nozzles can be either uh, high velocity nozzles or low velocity nozzles. You can see the orifice size. Okay, based on the orifice size, we can identify whether it can provide us low velocity or high velocity speeds. Okay, so usually this one is used for high velocity nozzles. Okay, high pressure discharge, and here the orifices are less, usually for the low velocity nozzles, and orifice diameter is also far more greater than the high velocity nozzles. Okay. Then we have the dry chemical systems, dry chemical powders, as we were discussing. Let me see. This is one of the application where a dry chemical powder has been applied. So you can see here the whole room has been completely filled with powder. So now what happens here? The next hectic situation is the cleaning of the powder. Okay. Now the cleaning becomes very difficult for us. So that is why the dry chemical powders need to be the major problem, the major hazard for the dry chemical powder. The major limitation is the residue itself. Now in the library, chairs, table, everywhere the dry chemical powder has been accumulated. So it becomes difficult for us to clean the whole area. Okay. So these are other requirements. Okay. Like for an extinguisher. Now requirements that are available, okay, based on the NFPA codes. Okay, so like for example, what is the maximum distance of travel that we should have? Okay, a maximum area that should be protected, you can see here 2A. Okay, so 2A means A. What is A? A is the, you can see here 10 gallons of water. Okay, so 8A means 1.25 means 10, means that it's going to cover up for 10 gallons of water. So like this 1A, 2A. Okay, so A is 1.25, so multiply by 2, so you'll get the gallons of water. Then 6,000 for light hazard occupancy and 3,000 for ordinary hazard occupancy. Okay, the area to be protected. So similarly, if you have 3A, 9,000 square foot of an area, that needs to be protected for light hazard occupancy, and ordinary hazard 4,500 square foot of an area that it will be used to be protected. Okay, so basically each and every extinguisher is being provided with a rating, and once a rating is provided, we tend to identify 10A. Okay, means A means the multiplied by 1.25 gallons of water. Okay, and then B, 20B means 20 square foot area, 10B means 10 square foot of an area. Okay, so like this we tend to provide ratings for the extinguishers. So each and every extinguisher will have a rating of, let's say, it will have 2A, 10B, C. So it means 2A means 2 multiplied by 1.25 gallons of water. Okay, and then it means that we have 10B means 10 square foot of an area that we need to protect. Okay, so you can see here the placement for the class B. Now these are all extinguisher requirements based on the NFP codes. Okay, but remember one thing, in the NFP12 NFP10, okay, if they're going to ask any question in the CFPS, okay, so specifically they are not going to carry out the whole questions. Okay, they will take only one perspective, the perspective that is used for the point of explanation, that can be considered as a question. So the whole table or anything we are asking from the question is not from the table, is not going to be there. Like for example, now minimum rated for minimum rated a single extinguisher. Now this is something that is minimum rating. We can have maximum rating also, we can have more rating also, but what is the minimum rating that is required? Now this is something that can be asked in the examination. Okay, so for light hazard it's 2A, ordinary hazard 2A, extra hazard 4A. Maximum floor area, okay, for light hazard 3000 square foot of an area, ordinary hazard 15,000 square foot of an area, extra hazard 1000. So this is something that they can ask in the examination, because this is something that can be used for explanation. Like for example, maximum travel distance to extinguisher, you can see here it is 75 feet. Now, why do we require the maximum travel? Because each extinguisher is actually, whenever an extinguisher is placed, okay, each extinguisher is placed to protect that specific area. Okay, like for example, sometimes we have multiple occupancies, mixed occupancies. For example, if you are, let's say that if I'm going through take an example of a marine. Okay, I'm traveling through marine. Okay, now I have a turbine as a turbine enclosure, steam engine or turbine enclosure at the bottom. Okay, and then I have one marine accommodation on the top. Okay, so for example, if in the turbine enclosure is giving any type of flame or any alarms, okay, so the whole, of course, the accommodation will be active because of the fire alarms. When they will try to fight out a fire, they cannot remove the extinguisher available in the accommodation, and they cannot take it to the turbine enclosure. The extinguisher that is available in the accommodation is meant for that area only. So once they will go down, if they take extinguisher, let's say that they have carbon dioxide extinguisher. Now they were going down, they go into the turbine enclosure. The metal is on fire. They apply carbon dioxide there. What will happen? It will propagate the flame, right? So that is why the extinguisher that is available in that area should be used for that specific zone. So that's why we usually say the travel distance of the extinguisher or the area, maximum floor area that it should cover, it should be known. Okay, so this information provides us information that if there is any type of a mixed occupancy, so what is the maximum area that my one extinguisher should be used, and based on that I can increase or decrease the rating. Okay, and for the next area, if it requires a different type of an extinguisher, then I can use that type of an extinguisher for that specific area of protection. Okay, so for that purpose, in mixed occupancies, the area of protection is very important. The maximum floor area that an extinguisher is covering is also very important. The maximum distance to an extinguisher is also very important. Okay, so usually in light hazard occupancies where the flame propagation is also light, okay, it's not that much high, so we can have maximum area of maximum travel distance. But once the probability of flame propagation is higher, means moving on towards ordinary hazard occupancy, then I can reduce it to lower distances. For example, if a light hazard is 75 feet, I can have 50 feet for ordinary hazard. Okay, I can have even much more less for the extra hazard. Okay, so the travel distance also depends upon the type of the materials. So in the start basics of fire and science, we discussed one thing, and that thing was the characteristics of the material. Okay, the characteristics of the material are going to define you everything. What type of extinguisher you are going to use, what area you are going to use, and how much travel distance you have to keep it for that area. So this becomes more and more challenging when you have mixed occupancies, means mix different types of occupancies with different types of materials available within each. So you have to then use your engineering evaluation. Okay, usually in the NFP codes, you will find this terminology. In the NFP code for the extinguishers also, you will find this terminology, that any other exceptions may require engineering evaluation. So what is the engineering evaluation? Meaning that based on your understanding, you identify that, okay, this extinguisher requires very less area, and I don't want it to be confused to be used in any other occupancy. So let me use a lower rating extinguisher. Sometimes you will see that carbon dioxide cylinder is only installed for 2 kg. Okay, only a 2 kg small extinguisher is used. And then you go a couple of steps forward, you will find water extinguisher or mist extinguisher, okay, or a
Which is
foam
very nice.
extinguisher of much more higher rating. Yeah. So the major limitations that we have discussed of various extinguishers, okay, it includes the limitations that are related towards the extinguishers is on property. Sometimes residues, sometimes their own chemical property, sometimes if their nature of solubility. Okay, so they all add up together to become the limitation for the extinguishers itself.
Can I take this cup and
Yes. Any questions? Okay. Let's move on and discuss about the wet chemicals. Wet chemicals, okay, they are more specifically used for class K fires, kitchen fires. Okay, and whenever we are seeing wet chemical fires, usually what happens that organic, inorganic salts, whenever they mix with water, they form an alkaline solution. Okay, and this alkaline solution can be discharged from a piping. Okay, so organic or inorganic salts mix with water to form alkaline solutions. The important condition is, but the important information here is that why do we require organic or inorganic salts to be mixed with water? Okay, so for the first, so for that purpose, let's discuss what are the wet chemicals and how they can be used very effectively. For that purpose, I'm just going to use one type of a scenario. I'm just going to use only one type of a scenario in which I'm going to explain that how wet chemicals can be effective for kitchen solutions. So then we can relate it towards other portions of the kitchen. So let's say if I have any type of a hood that is available in a kitchen, and this hood is a canopy type of a hood. A canopy hood is the hood that has lower edges. And why does it have lower edges? It's because it wants to extract maximum amount of heat and smoke from the oils, cooking oils that is being burned, right? The purpose of the hood is to extract all the heat, smoke, creosotes, anything that is being released from the vegetable oils or animal oils, fats, okay, from the ducting system outside of the facility. Now, whenever smoke or heat or the combustion process is going on, what happens? We have discussed that whenever a chemical decomposition of a material is done by heat alone into one or two products, okay, it is known as pyrolysis. Similarly, when a vegetable oil or animal oil is also burned or it's going through heat process, okay, creosotes means byproducts are usually released. Now, what happens in the byproducts? Okay, this you will usually find in our house kitchens also. We'll see that some type of greasy formation is usually accumulated. Okay, maybe sometimes you will find it here also on the bottom of the hood. This greasy formation is usually available. Now, whenever a flame appears in a kitchen, what happens? The most important point that usually we say that in kitchen fires, okay, kitchen, someone left anything available in the kitchen, okay, it burned completely, and fire started from kitchen and propagated towards the whole building. So what usually happens in the kitchen fires is that this greasy formation that is usually formed, it has two very important characteristics. This greasy formation, okay, first of all, it is highly flammable. And any greasy material is an insulator for water. Water is insulator. Why? Because water will only skid off towards the grease. Usually you'll see that whenever we apply grease towards the terminals, okay, why we want to do is that we don't want any liquid formation to be there so that corrosion may not occur, right? So liquid will always skid off from the greasing. So once a sprinkler activates also, the water will usually skid off from the greasy formation. So what will happen there? Okay, in this case, the flame will propagate, it will continue to burn, okay, and it will burn up to an intensity where it's going to propagate outside the hood, eventually covering up the whole kitchen. And since some in worst case scenarios, it may also cover up the all occupancy also. So usually what we want to get rid of this greasy formation. So there we come and we tend to introduce our wet chemicals. Now, what does the wet chemical do? We have salts, okay, organic and inorganic salts, okay, that we mix with water, alkaline solution is formed, okay. Now, these wet chemicals, they are usually expelled, okay, under gas pressure, okay. They are in the tubing, okay, whenever they are expelled under gas pressure, okay. So whenever the wet chemicals are used, what it tends to do, wet chemicals mixed with water, okay, they react with a greasy material, okay. And what are the wet chemicals that react with water? So the chemicals that react with water are usually a combination, okay, is potassium carbonate. The chemicals that we can use, potassium carbonate, uh, potassium citrate, and the third is potassium acetate. Whenever these three chemicals, a combination of these three chemicals is mixed with water, usually other additives are also there, like phosphoric acid is usually also added. So what it tends to do, okay, it reacts with the greasy formation. Wet chemicals applied with mixed with water, applied on the greasy formation. Now, whenever they are applied on the greasy formation, this greasy formation converts to a soapy formation. Okay, this greasy formation converts after the application into a soapy formation, and it flows out of the hood system, cleaning the whole hood, removing the greasy formation. Okay, so this whole process, application of a wet chemical, okay, to remove or convert the greasy formation into a soapy formation, this whole process is known as the process of saponification. Okay, this whole process is known as saponification, and it can extinguish or remove the greasy formation or extinguish the fire also. So these wet chemicals can be expelled through the sprinklers and nozzles also. Okay, so wet chemicals, they use the chemicals, application of chemical to remove this greasy formation and convert it into a soapy formation. This whole process is known as saponification. Okay, in the saponification process, we clean the kitchen hood. Now the this greasy formation is not only in the hood, in various portions of the kitchen, we found this. So whenever we want to clean this one, okay, we can use a wet chemical and we can rub it off. We can clean it off throughout the whole kitchen so that no flammable material is available inside the kitchen. Okay, so the wet chemicals are used for kitchen fires very effectively because they perform the process of saponification. What is the process of saponification? Application of wet chemicals to remove the greasy formation, and how this greasy formation is removed by converting them into a soapy formation. One of the example of greasy formation to soapy formation is usually in our kitchens also. Whenever we are cleaning any type of utensils after the cooking, okay, we have liquid oil that is available. Okay, so if I want to just with plain water, if I want to clean that one, I cannot do it. Okay, the water will always skid off. Oily nature will always be available there, right? So what I tend to do, I use a type of a sopping liquid that is also citric in nature. Okay, usually you'll see that the dish liquids are usually lemon, citric, acetate. Okay, so what we use a citric type of a liquid, okay, mixed with water, and then we try to clean it up. What happens? More and more soapy formation is usually made, and then when we clean out the whole utensil is cleaned out. So that can be related towards what we are doing here in wet chemicals also. Okay, so in wet chemicals, we do the same thing. We mix chemicals with water, convert that greasy to soapy formation, and this process is known as saponification. And saponification process we are doing also in the kitchens. Okay, so that is one way of understanding the wet chemicals. Now the problem here is that to see what are the limitations of the wet chemicals. Okay, so let's see what are the limitations of the wet chemicals. Now, limitation of wet chemicals include everything that includes water. Why? Because water is there. So whatever the limitation of water will be there, that will be the limitation of wet chemicals. Like for example, water is incompatible with reactive wet metals. Wet chemicals are also incompatible with reactive metals. They have limitation with reactive metals. Water cannot be used on electrical energized equipment, right? So we cannot use electrical energized equipment. Third, one limitation that it has is lime dust. We cannot use wet chemicals with lime dust. That is CaO. It is not compatible with that. Okay, it may tend to give too much vigorous reaction. Okay, what is lime dust? Where do we use lime dust? Anyone? Lime dust. Sometimes whenever our sinks, they are blocked. Okay, so we use any type of a white powder, right? And what we do, we apply hot water, we leave it there. So what it happens, it tends to absorb that. Whatever is blocking the whole sink, it tends to clear out the whole sink, right? So that is the lime dust. Okay, so usually in sinks, kitchen sinks, in any type of sanitary, okay, we use lime dust. It's usually available. So whenever you are going to apply wet chemicals for cleaning process, just make sure that a lime dust is not already applied because it tends to give off fumes, okay, or vigorous reactions may also occur. So that is why we don't use lime dust with wet chemicals. It has vigorous reactions with it. Yeah. So what are the extinguishing properties? Because water is there, so it will have both of the extinguishing properties that water has, okay. It will have broad the properties. The first property is smothering action. And the second one is cooling action. Because water, we have discussed, water has the highest heat of vaporization, right? A latent heat of vaporization. It can absorb maximum amount of heat. So that is why it can have a very good, it has a cooling action. Okay, so it performs only two extinguishing mechanisms, that is smothering action and cooling action. Carbon dioxide also oxygen displacement and cooling action or smothering action, you can say. Wet chemical smothering action, cooling action, and dry chemical powder has all the four extinguishing mechanisms. Okay. So when we were saying that the sprinklers, okay, a highly pressure gas is usually required to expel wet chemicals. Okay. So what type of gas is usually required? Okay. So highly pressurized gas is usually required to expel wet chemicals. Okay. From nozzles or sprinklers. Okay. So this type, the pressure, highly pressurized gas that is required is nitrogen or carbon dioxide. Okay. These two gases are usually required because they are cold and they can easily remove highly pressurized, they can remove liquidify form from the sprinklers and nozzles. So they can expel wet chemicals from the piping very easily. So the gases that tend to use for expelling wet chemicals are nitrogen and or carbon dioxide. Whenever the wet chemicals are usually stored, okay, storage, what is the only limitation that we have to keep for the wet chemicals? Only limitation, okay, for the wet chemicals is that we have to make sure we should know, we are well aware of the freezing point of the chemical. Freezing point of chemical, okay. Why? Because wet chemical, once it freezes up, it will convert to solid, concentration is diluted, molecules are dispersed. So for that purpose, whenever the wet chemicals is being stored, the only consideration that we have to keep in contact is the storage, freezing point of the chemical itself. Yeah. Okay. So these are for the wet chemicals, okay, and used for class K fires, okay. So whenever there are class K fires, we use wet chemicals very effectively. Okay, and anything, any questions on wet chemicals? Okay. And one more thing, and storage. Yes, plastic containers. Plastic containers. Okay, if I want to store wet chemicals, I can store up to 5 gallons in plastic containers. Okay, so up to 5 gallons of wet chemical can be stored in the plastic containers. Okay. Any questions? Wet chemicals? Okay, let's move on and let's discuss about the dry powders. Okay. So dry powder extinguishers. Dry powder extinguishers, okay, they are meant to use for class D fires. Right? They are meant for use on class D fires, dry powder extinguishers. Okay. Dry powder extinguishers, what they tend to do is that, okay, they are usually used on combustible metals, okay, highly combustible metals where the temperature is above 1200, 1400 degrees Celsius, okay, where the metal may burn more rapidly and more violently, okay, there we need dry powder extinguishers to be used. Now, what should be done whenever you are going to apply the application process for the dry powder extinguisher is that whenever you're going to apply, okay, the metal should be covered in 1 to 2 inch layer of dry powder. Okay, the dry powder should be 1 to 2 inch in layer that should be covering the whole metal. Okay, then comes the quantity of the composition of the dry powders. Okay, so dry powder comes in various compositions. Okay, one of the composition is the wheeled models. Okay, the wheeled models, okay, they go from 69 kg to 159 kg of dry powder, okay, and the chemical composition is sodium chloride plus any type of a thermoplastic material. Okay, as the temperature becomes higher, the composition becomes more and more harder. Okay, so same like baking a cake. Usually we keep all the formation, baking powder, everything, all formation into the oven. We provide a specific temperature, a crust is formed. Similarly, a crust is usually formed on the top. Okay, and this crust that usually forms on the top, okay, that can usually have a crust formation on the top like this that can cover the whole metal. Okay, so this crust can be as long as up to 6 to 8 feet, has a range of 6 to 8 feet. Okay. Okay, but I have the second composition of the wheeled model, which may require to have large quantities of sodium chloride, large quantity of dry powders, bulk form. So in bulk form of dry powders, we change the composition. Okay, in the bulk form, okay, the composition is sodium chloride plus graphite plus phosphorus. This graphite, okay, and phosphorus, they are also known as G1 powder. They are also known as G1 powder. Bulk form means more and more quantity. So means much more higher temperature, we can use this formation. Sodium chloride plus G1 powder we can use very effectively on fires. And what it tends to do, each and every has its own properties. Like graphite. Graphite is a very good conductor of heat. It cools the metal. It absorbs very heat too much quickly. So graphite is a good conductor of heat. Okay, it cools the metal. Whereas phosphorus, what does phosphorus do? Phosphorus, okay, creates vapors, okay, and prevent air from reaching the metal, prevents air from reaching metal. So vapors are usually formed around it, so that air cannot reach towards the metal. Limitations of dry powder extinguisher. Limitations again is based on the residue. That is available. Okay. The residue is very difficult to, of course, clean. Okay. And usually we don't use it on any other A, B, and C fires. Okay. Because it is going to completely spoil the whole product. The hard crust that is going to form is not applicable for ABC fires. Okay. So the hard crust that requires, first of all, it requires higher temperature to form the hard crust. And usually the hard crust may not be formed, okay, if the temperature is lower. So usually we use metal fire. And when the crust is broken down, okay, we can break down the crust and we can clean it out. The metal will be again in the form that is required for us. So we can use it very effectively there. Dry powder extinguishers comes in various different forms, okay, as we have discussed. Two compositions. One is the build models that has less composition, and one is in the bulk form, which has more concentrated, more composition, which means that we can handle large quantities of metals or even larger temperatures. Okay, so metal fires, dry powder extinguishers, they provide two very important extinguishing mechanisms. Okay, if we talk about extinguishing mechanisms, okay, yeah, the first thing is that smothering, okay, action, cooling action, because it absorbs maximum amount of heat, and it also breaks chemical chain. Plus, it provides radiation shielding. So same like dry chemical powders, it has all the four properties. Okay. But dry, it cannot be. It's not preferable to use on ABC fires. Okay, can be, but it's not preferable to be used there. Okay, the formation actually spoils the whole product. Okay, so dry chemical powders, on the other hand, okay, they can be easily removed, easily can be cleaned. Easily means easily cleaned under dry powder extinguisher, because when they become hard crust, more stickier in nature. So it defines that. And the second thing is that the composition is not suitable for the humans. Okay, so because graphite, phosphorus, and sodium chloride, okay, once they accumulate, they provide much more toxic environment than the dry chemical powders. So that's why they are not meant for ABC fires. Okay, so let's discuss about the clean agents. Clean agents, any agent can be considered to be clean if it has three properties. Okay, what are the properties of clean agents? Okay, so if it has three properties, the first property of any agent to be a clean agent is that they are electrically non-conductive. Second property is that they can vaporize and leave no residue. Okay, and they are all liquefied gases, means compressible liquids. Means they are compressible liquids. These are the three important properties of the clean agents. So what about the halon gas? Halon, HEL. Halon. Is it a clean agent or not? This gas, halon gas. It's a clean agent? Yes, it is a clean agent. But environmentally, it's not clean. Okay. Environmentally, it's not clean. Okay. Because of Clean Air Act, CAA, Environmental Protection Agency, EPA, okay, for them, it's not clean. Clean means it's not environmentally, it's not suitable for the environment. It's damaging the environment. So that is why it is a clean agent, but environmentally, it's affecting the ozone layer. That's why we don't use them. We don't use the halon gas. But anyways, let's see what are the, in which category the halon gas it tends to fall out. Okay. Okay, so the clean agents, okay, when we're talking about, they are usually categorized into two types. One is the compounds, and the other ones are the inert gases. When we are talking about compounds, okay, the compounds or halogenated agents with compounds, they include carbon, hydrogen, fluorine, chlorine, bromine, iodine. So these are the compounds. And when we are talking about the behavior, okay, of the gases, okay, so there are various different types of gases that are available. Like for example, we have halon gas, okay. Now halon gas included all. It had included chlorine, okay. Then it included bromine, iodine, bromine or fluorine, then iodine, and then it included hydrogen, oh sorry, carbon and hydrogen. So that was the formation of halon gas. Okay. Similarly, when we are talking about our FM200, okay, so FM200, okay, it includes hydrochlorofluorocarbon, fluorine, chlorine, okay, and then we have carbon, yes, hydrochloro and hydrogen. So it includes all these four. And then we have Novec. It's usually considered to be fluoroketones, and fluoroketones means that it has usually it has let's say carbon, okay, then it has fluorine, fluoroketones, so it has fluorine, okay, and it has one oxygen also. Okay. So what is the difference between FM200, Novec, and halon? Means they all are compounds at some extent, right? So why halon is banned and FM200 is applicable and Novec is considered to be much more appreciable or much more effective than FM200 and halon? Any ideas? What is the major difference? Because of the clean natures, environmental effects, yes, we can say that. Both are right. Halon, when it's released into the atmosphere, it remains in the atmosphere for 155 years. It remains, sorry, it remains in the atmosphere for 155 years. FM200 remains in the atmosphere for 25 years, 20 to 25 years. Okay. Global warming, yes. Novec, on the other hand, remains in the atmosphere because it has one atom of oxygen also, means oxygen is also there with fluorine and carbon. Okay. So it remains in the atmosphere for 0.015 years. Okay. Once released in the atmosphere, halon is banned by two. Overall, he is regulated by the EPA. Halon is banned by the EPA. Halon itself is banned by CAA, Clean Air Act, and the Environmental Protection Agency, EPA. Because of its availability in the atmosphere. Okay. On the other hand, we have inert gases. Now, inert gases, okay, they are considered to be the gases that are usually available in the atmosphere. So, inert gases combination is usually argon, nitrogen, and at some extent, we also have carbon dioxide that is also available in the atmosphere. Okay, so these three are usually available with us. So when we are talking about the inert gases, they also usually come in compositions in models, okay? And their model starts with IG01. IG01 means that it contains 100% of argon only. No other one. Okay. Then we have a second combination, second formation, that is IG100. IG100 contains only nitrogen. The third is IG541. Inert gas 541. It contains nitrogen 52%, argon 40%, and carbon dioxide 8%. Okay. Then we have the third, fourth, and the last formation, that is IG55. Inert gas 55. Inert gas 55 contains nitrogen 50% and argon 50%. Okay. So these are the compositions for our inert gases. So first composition IG01, then we have IG100, okay, then we have IG541, and we have the IG55. So these are the four compositions for our inert gases that are available. Okay. So inert gases are very effective. Why? We have already discussed. If you want to remove oxygen, okay, removal of oxygen is very effectively done by carbon dioxide, because carbon dioxide, first of all, is available in the atmosphere. Okay. And on the other hand, it's a cold gas. Okay. Compressed, whenever it's compressed, it's a very cold gas, right? So carbon dioxide can be very effective in the removal of oxygen, but if in any case you want to remove carbon dioxide, okay, we can use nitrogen as a very effective agent to remove oxygen, okay, because the nitrogen concentration in the atmosphere is 79%. So it can be used very effectively to remove oxygen from the top of the fire. Okay. So that's why we use inert gases also as a type of clean agent, which are environmentally friendly and we can use them very effectively. But of course, they have their own limitations because of the reaction time, which is slightly a type of a delay. Okay, other than the compounds, but the compounds, the major issue is that they are toxic in nature. Okay, they may be toxic in nature. Sometimes, whenever any other type of environment is available, moisturized environment available. Okay. Second important thing is that they tend to remain in the atmosphere for far more longer, which can damage the ozone layer. So that is why the environmental agencies like Clean Air Act, environmental protection agencies, and one more National Oceanic and Atmospheric Administration (NOAA). Okay, so these organizations, they tend to keep a very close eye on the clean agents that are being used nowadays. So that is why Novak 1230, you will see that it is much more expensive and much more preferable by various organizations that tend to move on towards sustainability. Okay, so they tend to sometimes, like organizations, when they are saying, okay, we are not what is the one step that we can take to move towards sustainability. So it's just by replacing your extinguishing agents, by replacing your clean agents. Okay, so you move on towards sustainability. So you'll see that most of the organizations, when they are saying that we are sustainable, it means that they are using products, they are using materials that are environmental friendly. So like this, Novak 1230 is much more friendlier, okay, than FM200 and halon gas. So halon, but among all these, if we are going to say that which one is the most effective and the most effective agent as compared to cost and its extinguishing properties, it will always be halon gas. Okay, halon was the most cost effective and the most you can say extinguishing agent, effective extinguishing agent than any other gas. But because of its environmental issues, it has been banned. Any type of chlorofluorocarbons, okay, they were banned in 1990 by the Clean Air Act. Okay, and once they were banned, after 10 years, means by 2000, it was made sure that the production of chlorofluorocarbons were also limited. Okay, and they were converted to hydrochlorofluorocarbons. Okay, so like for example, our refrigeration agents. Okay, when we'll be discussing about the refrigeration in the building services section 10, there also we'll discuss that the clean chlorofluorocarbons were banned. Okay, and then we shifted to hydrochlorofluorocarbons as CFCs, and it took almost 10 years to completely stop or halt the production for chlorofluorocarbons, okay, by the Clean Air Act. Okay, so this is for the clean agents. Okay, guys, so what we have discussed today, we have discussed about various different types of extinguishers, starting from the carbon dioxide, dry chemical powders, and we have also discussed about the wet chemicals and dry powders and the clean agents. Okay. Uh, whenever water whenever sprinkler system is not available or we want water to be omitted from any type of an occupancy, okay, then carbon dioxide and dry chemical should be available there. If carbon dioxide and dry chemical powder both extinguisher are available, then water may be omitted. Okay, means that water may be omitted, no issues. Okay, but each and every building as per the NFPA 13, NFPA 101 guidelines. Okay, NFPA 101 and NFPA 13. NFPA 101 is the life safety code. So, as per the NFPA 101 guidelines, all buildings should be protected by sprinklers. Okay, but in any case, let's say that if water may be omitted, if you want to omit water due to any case scenario, because of any other scenario where you don't want the material to be wet or you don't want the components to be failure. Okay, means like any type of server rooms. Okay, where you don't want accidental leakage or activation of the sprinkler to completely short circuit modems modules. Okay, so for that purpose, okay, you can use carbon dioxide and dry chemical powder in replacement of water. Okay, so water may be omitted if the carbon dioxide and dry chemical powder both are available in the occupancy. Okay, So this is all for today's lecture. In the next lecture, we will complete the section 17 by discussing the form systems. That we'll be discussing about the AFFF forms, triple FT forms, lower temperature forms. Okay, and then we'll see what are the antidepressing agents that are usually used inside the form systems, so that the form system can be used at a lower temperatures. Then we'll discuss about the characteristics of the forms, in which we'll see what are the extinguishing mechanisms of the forms, okay, form systems, and why they are considered to be one of the most effective agents only for the liquid fires. What are the limitations of AFFF and triple FP forms? And then we will end the discussion of the form systems, and then we'll be moving on towards the sample questions that we'll discuss from section 17. After the questions, we'll move on and discuss about the next section, that will be section 16, water-based suppression systems. Any questions that you have for today, you can ask now. Actually, no one did. Yeah, no issues. The first thing I'm going to do after the ending of the session, I will just try to let me just share it now. Yeah. Okay. Just a second. Yeah, my WhatsApp is also actually okay. I'll just do it right now while you people are here. Okay. Okay. Yeah. No, this is CFPS 1034. This is the one, right? 1034, right? Okay, I think so. I don't have this badge with me. I'm not the admin there, man. Okay. CFPS 1034. No, it's not. Okay, what I'm going to do here is that I'm just going to share the notes with the coordinator. Okay, and I'm just doing it now, so she can provide you. Okay. Uh, Basics of fire science. Okay. Then we have detection and alarm. Okay, and we have fire suppression without water. Okay. So I'm doing it now, as well as with the test also. Okay. So the test that we did were physics of fire science and detection and alarm. Okay. 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 Okay, what is the deep-seated fire? Okay, deep-seated fire. Okay, highlight handbook with any samples or demo videos or something. Yeah, we can do that. Yeah, just a second, we'll discuss that. Okay. Okay. Deep-seated fire. Okay. Any type of fire below structure. Okay, which is very difficult to approach. Usually, we say that confined spaces, right? So for this purpose, we have a different type of extinguishing mechanisms that is usually done. Okay, and for that purpose, sometimes, like in confined spaces, okay, sometimes if the confined space is below a structure, we know that the form system will tend to settle down. Okay, and we can use it to provide extinguishment. But in some cases where the structure is completely different, you know. Where the structure is totally occupied with obstructions and the confined spaces at a furthermore depth. Okay, so what we tend to do is that we have nozzles that can spray carbon dioxide, because carbon dioxide is heavier than air. Okay, and it tends to settle down always. Okay, so we can apply carbon dioxide in that area. So deep-seated fire, usually different types of techniques are there, but it depends upon the depth, it depends upon the confinement, and it depends upon the availability, whether it's manned area, unmanned area. And based on that, we can provide extinguishment processes in different ways. We can have nozzles placed for the carbon dioxide extinguishers. We can have nozzles that are that we can use if the confined space is just only a confined space, not that much narrower, where the heating cannot be accumulated that much. You can use nozzles and sprays water to spray confine to spray the foam system also from nozzles and sprinklers like AFFF can be sprayed from nozzles and sprinklers. You can use that. Spacing for extinguishers as per NFPA to be by hearted. No, it's not required to be by hearted. Uh, Look, in the CFS examination, the questions related towards the codes are not there. Okay, their always concentration is not on the questions related towards the codes. Their focus is always based on the principles that are behind the codes, meaning like they may ask you about the physical and chemical. Their concentration is focus is more on the physical chemical concentration characteristics of the material itself. Like if I'm going to say about the carbon dioxide extinguishers, okay, so the only thing that they want from you is that to know what is the whether you have understood the limitations, whether you know the weakness and strength of your devices. So that is what their focus is always on. So why? Because NFP10 has requirements, NFP12 has requirements. So it's not about the codes itself. CFPS will never focus on the codes. They will. They may ask a question about the code. That, as I was saying, that they may ask about the minimum means the minimum rating for extinguisher in light hazard occupancy. So it's a 2A for light and has ordinary hazard. Minimum area, maximum area per square foot that is required, 1500 square foot for ordinary light hazard and for 3000 for ordinary hazard. So like this, I mean, they can always ask you questions, but but as exact distances, exact height or something like that, they will not ask. Okay, or any type of travel distance, maybe very less chances. Like if we want to say but the percentage, in percentage, like there's very less percentage, like 5 to 7% chance is there that they may ask you about the travel distance, but usually they will not ask. Their focus is more on the logical explanation of the devices. They focus very less on the device, on this codes itself. Okay. Okay, highlighting the book. Okay, I have given you the slides here. Okay. Okay, so what you have to do, you have to just simply take the notes. Okay. Sorry about that. What you have to do is that you'll take the notes. Okay, the slides that I have just forwarded to the coordinator right now. Okay, with the test, sample test. You'll use that notes. Okay, just read out the notes and compare that notes with the fire protection handbook. Okay, so whatever you find it out from the notes, if you find it out in the book, highlight it. Okay, because the notes are the most important points that are available from the fire protection handbook. Okay, so it's not going to be like, it's not like we have captured out throughout the whole chapter. So let me just show you the screen and show you the fire protection handbook. Okay. Okay, yeah, this is something I've just shared it now. Okay, and is the fire protection handbook. Okay, here's the fire protection handbook. Okay, so what I'm going to do here is that let's see what are the sections. Let's go basics of anthems. Okay, so here it is. So see here. Now, whatever is in the slides, okay, it's available. So now I have highlighted this. This is available in the slide. Okay, so I've highlighted this. Okay. Now, formulas, calculations, they are not part of the examination. Laboratory testings are not part of the examination. So, but they can ask you like, what is the Q loss? And if you remember in the first test, we have discussed this question also, or heat loss from the surface. Okay, Q flame is the heat flux from the flame to the surface. We have discussed this in the maximum burning rate, right? So that's why I've highlighted this one. This is available in the slides. This you highlight. Okay, so when you'll go down, you will see here now heat transfer mechanism. Okay, so see whatever the first line, I mean definitions. Okay, offset values. Okay, and bimetallic like this, I've highlighted it. Okay, so whatever is in the slide, it's available there. I've highlighted it. These are the important points. Okay, then other than that, if you go down, okay, British thermal unit, latent heat of fusion of water values are there. This is available in the slides. Okay, the other all these portions are unnecessary portion for the examination. So you can see here, all these portions are only examples, testings, and everything. So I have not highlighted it. But in the slides, I've used these points, and this is what I have highlighted here. So like this, you have to highlight it. Dry air concentration, okay, buoyancy, okay, up to the definition where you can understand it. Okay, then latent heat of gasification. Then all these points. Now you can see here. Now this all is calculation. Calculations are not part of the examination. They are not even in the slides, and they are not even there. Okay. So conduction. Okay. Then we will move on. Then we have like this all are calculations. No need. Convection. Okay, calculations again. Graphs, they are not part of the examination. Skip it out altogether. Radiation. Okay, so like this you will see what are the values that are important. See here, these are the graph that we have discussed about the cosmic rays, gamma rays, X-rays, ultraviolet, infrared, radio waves. If you remember, we have discussed this graph. Cosmic rays has the lowest values, right? So like this we have discussed it, right? So this is important. So that is, this graph is available in the slides, so you know that it is available. So absorbability we have discussed. Black surfaces maximum absorbability, shiny surface less absorbability, less than 0.1. So this all you can highlight, but other than that you can skip it out. Okay, so like this there are some premix flame, diffusion flame. Okay? So like this there are certain materials that are available. Fire chemistry, we have discussed about the definitions, right? So you can just highlight that one, highlight the definitions. Okay, like this you have to highlight it. Okay, other than that, I mean, we cannot expect it, but these are the major points that are, where the examination questions have already been coming from. So you can see here that other questions are like chain reactions that are not part of examination. Okay, so that's it. Like this, I mean, you have to highlight the whole book. Okay, I mean, you have to highlight the book itself. So this is one of the, you can say, slides. Take the slides and highlight the book. Take the slides and highlight the book like this. Again, whatever, if you are highlighting something and you are reading it, it's important that you only highlight it. Okay, why? Because you should know where that data is available. That is your practice. And during highlighting, if you are understanding some things, like for example, you find it, okay, now this is something that I'm understanding, it's interesting for me to read, then you can read further also. The information is amazingly available in the fire protection handbook. Too much information is available. Okay, so what we are teaching here is actually the explanation of what is written there. So it is very informative book. Okay, if you can find it more and more reading, it is more informative. It will automatically enhance your knowledge. Okay, it will bring you to a point where you are like you are equal to a person who is working like 10 to 15 years, who has experience in firefighting. So once you start understanding things, you read these things, you learn the terminologies, you understand the concepts, you take yourself, you give yourself a boost in the knowledge. Okay, so other than that, this is one of the ways which you have to do with your hardbound. Okay, so just read out the slides and you yourself highlight it so that you will get practice where the just topics are available. Okay, so this will help you in the examination also, so that in examination if a question comes, you know, okay, this question is from basics of fire and science, you save time, you know which chapter it is available, it saves more time for you. So more the time you save, the more chances you are going to pass, okay, in the first attempt. So it's the struggle that you have to do a little bit effort. So I've just forwarded all the notes and everything to the coordinator. She will be sharing with you guys on the group. Okay, and you can just start doing the practice accordingly. But in the end, when we'll be moving on towards end sessions, we will have the mock examination. We will discuss the mock examinations live, okay, and we will see how we can practice it out. Okay, so what are the questions that are more favorable to come in the examination? Okay, but remember one thing: most of the students, they want to go for more and more questions that are available online. At the end of the day, it's you have to go there, you have to sit it out, you have to pass the examination. Okay, so no matter how many questions you are going to solve it, it's not going to help you unless your concepts are not clear, unless you are not familiarized with the book. Okay, no question bag is going to help in the examination, remember that. Don't put any other further costs in the question bags. We have question bags, we'll share with you, but that is for practice. Don't consider it as the final questions or repeated questions that are going to come. Okay, eventually the certificate advisory group always changes the question. We have been the member there, we know what we are going to do. Okay, they will always change the questions. Okay, they also know what questions are there in the market, and everyone is making customized questions. We have 500 questions, we have 800 questions, and we are selling for $20, $40. They don't even know what is the, the blueprint. So for that purpose, it is very important for you guys to just focus on the book, get familiarized with the book yourself. Okay, use the notes and familiarize with the book. Use the questions that I'm sending you, the test that we are solving, just make them bullet points, so that 1 or 2 days before examination you don't have to uh, review the whole book. Okay, you don't have to review the whole 3,800 pages. Okay, so what you have to do is you just simply go for the bullet points as revision. Okay, so it will help you in that also. So these tests, you convert them to bullet points. Slides, highlight, use them to highlight the book. Okay, use this practice. A lot of students have passed the examination, and we have like in like 3 weeks I had 2 students who have passed the examination. One student in the first attempt, he has passed the examination, and they always give a feedback that in the end, if they follow the same instructions, in the end they have 15 minutes left for them to review more. Usually in the CFS we say that 3 hours 100 questions is very less time, but if you follow the same criteria, try to solve maximum questions close book, and that is why we are having this type of descriptive type of training. Okay, so that concepts are clear, you can solve questions close book. Once you are able to solve maximum questions close book, the more chances you is that you are going to pass the examination. Okay, so these are the techniques. Okay, but all in all, when we'll be moving towards the end, we will be using the index also. Where we have time for mock examination and index also. We'll discuss how we can use index, because in the end, index is also going to help us for some questions. So for that purpose, we'll move in there. Guys, any other questions? Okay, so I'll just be ending the session here. So the recording is downloaded. Okay. Usually recording takes a bit of time. Why? Because sometimes the uploading is very slow, and sometimes it breaks down between the uploading because the file is approximately 3 to 4 GB on the Google Drive. So it may take some time usually, but all in all, I usually say I ask students to be attending the class. Okay, don't depend on the recordings. Attend your class, make your notes in your class. Okay, make your own notes. Whatever I'm making, whatever you are understanding, make your own notes. Okay, make your own notes. Okay, and be prepared. Okay, means recording is just a revision. Okay, so usually it takes time, because when you am uploading it, sometimes any disconnection, the Google Drive does not upload it. And then the second thing is that once it's uploaded, okay, to make it available for the users, it takes some time. Okay, so it becomes difficult for us to arrange that also. Okay. Okay, guys. So I'll be just ending the session here. Have a nice weekend. Okay. Take care. Ramadan Mubarak.